We good to go? So I will kick off the Innovation Forum. My name is Justin Koozer. I am from Denver, Colorado in the US, and I'm the head of our global mining business at Klüber Lubrication. So today I want to talk to you a little bit about increasing the efficiency in the comminution process with very small changes and looking at the energy performance of specialty lubricants. So talking about who Klüber is. So Klüber is a specialty lubricants company. We're based in Munich, Germany. We're a family-owned company with presence all around the world, more than 35 countries, including 14 production facilities. And specifically in mining, when we talk about specialty lubricants, it doesn't mean that we're going to come into the mine and try to sell anything and everything. We only focus on the applications where we know that we can have an impact on the total cost per ton. And so what we're most well known for is the open gears found on the grinding mills. And so we have a full portfolio of the operational lubricants that can meet the demands of any situation, depending on how the size of the mill or the ambient conditions or the condition of the mill teeth. But we also have service products for this application where we can repair or clean the gear while it's in operation. But we're also looking at other solutions as well, like the HPGR and shovels on the open gear lubricants and mobile equipment. But today I'm mainly going to be focused on the gearbox application. So before we get into the lubricant side, I want to talk to you about what the challenges are in mining right now. So everyone's talking about sustainability, but let's all get on the same page and talk about what the electrical impacts of the mining industry are. So I know here in Sweden, especially in the north, you have very cheap energy, but you're using a lot of it. I just heard that LKAB is expected to be 40% of the electricity consumption in Sweden. And on a global basis, we're seeing that it's somewhere between 2 and 4% of the global electricity is used for the comminution process, so the grinding of the ore. And we think that this number is only going to rise as the world's hunger for minerals continues to increase and the ore bodies become less dense and harder to reach, that the electrical spend will become even larger. We're starting to see some of the governments starting to put in some regulations around this topic. So you see a lot, especially in Europe, with the ISO 50001 energy management. And we expect that as sustainability becomes a bigger topic in mining, that we will have even more. So when we look at why does it take so much energy to grind ore, it's mainly coming from the ball mills. So when we look at at a specific mine's electrical consumption, about 60% is coming from the ball mills. And these ball mills are highly inefficient. They work really well, but they lose a lot of their energy not going into the ore, but through friction losses and heat losses. So we started to think about this as Klüber, if we could have an impact, because at the end of the day, a lubricant's job is to reduce the friction. So if you don't know much about lubricants, if nothing else you take away from this is that every oil is not created equally. So when we start to design an oil, we go back to the fundamentals, and here what we have is in tribology, which is the study of lubricants, on the right side is the Strybeck curve. And basically the Strybeck curve is a representation about the friction in a particular application with relation to the speeds, the loads, the temperature, and the viscosity of the lubricant. So what we see is that when you have low speeds or low viscosity, the two bodies are in direct contact. So in this case, between a pinion and a gear, you have the surfaces coming into high contact, creating high friction. And as you increase the viscosity or the speed, you're going to be reducing that until you get a full separation of the tooth flanks up to a certain point that where if you continue to increase the viscosity or increase the speed, then the friction starts to rise again. That's because of this internal friction. So this is the balance that we have to face. But it's not only the viscosity that we have to select. We can also make an impact on this with the type of oil that we use or the types of additives that we use. So this is where we start off. And then we started to look at this in laboratory bench tests. So what I have here on the left side is the friction coefficient of 3 different base oils at 3 different speeds. And what we see is that there can be a dramatic effect on the friction coefficient. On the right side is a different test where we use an actual worm gear set where we're able to look at the energy consumption and calculate the overall efficiency. And it's interesting that you see, again, a big difference, up to 20% difference, depending on the type of oil that you're using. So that's all in a controlled environment in the lab. And everyone in the oil industry has known this for a long time, that depending on the type of oil that you use, you can make an impact on the energy consumption. But the difficulty became in the actual real world. How do you prove that the savings that you are expecting are actually occurring when you have, if we look at a mill gearbox, for instance, there's up to 30 variables which have an impact on the energy consumption. The challenge is isolating all those variables so that we can only look at the one change, the changing of the oil. So what Klüber did was we hired data scientists to help us with this, and we now have a program where we can come in and look at the conventional oil. We have an overall estimation about what all those variables could be. Then we're monitoring that for 30 to 60 days, and we're building a mathematical model to help us isolate that one change and keep so that we can really compare apples to apples, that this oil is operating at the same condition as our oil. So if we look here on the left side is this mathematical model. So the black line is the actual situation. We then use the regression analysis and are able to match that with the current situation with a high degree of accuracy. And then we make the change to our specialty lubricant, and we use that same model so that we're in the same situation, right? So this methodology works, and actually we can work with up to 30 variables and fix those variables. And actually our methodology is certified by a third party that it is conforming with international, the MVP, the International Performance Measurement and Verification Protocol. And because we conform with this, you have the option at the end of the project to receive a report from us that has full transparency on our methodology, and that you can hand over to your auditors for any energy audit, like an ISO 50001, or in the US we have the Energy Star. So I'll show you a couple actual business cases that we were able to do this. So the first one is on a ball mill. It was in the cement industry. It's a 5.5 megawatt ball mill. And in this case, they were producing 5 different types of cement. And what's interesting is so we have to look at not only the in-feed and the out-feed of the ore into the mill, but also the type of ore that's going in there also has an impact. So for instance, if the ore hardness is changing. So in this case, we were actually able to save the customer 6.5%, which was equivalent to almost 2.5 kilowatt hours per ton. And because every sustainability case needs to have a business case attached to it, we were able to show them a savings of more than 180,000 euros. So we have a nice video about this case on our YouTube. The next one is on the HPGR. And HPGRs are used in the replacement of the SAG circuit because they are more efficient. But what we find is that we can still have significant impacts on the overall consumption of the electricity. So in this case, we were able to show them a savings of more than 9%. And what I think is interesting here is that they didn't necessarily just take that money, right? What they were actually, that HPGR was constrained by the power consumption. So because we were able to reduce the energy consumption by 9%, they were actually able to increase their production rate. So it's not only about reducing the overall emissions or the overall electricity consumption, it's really about that kilowatt hours per ton that we can make an impact and actually allow them to free up space to produce any more. So even with all these proven cases, we still have some customers who are reluctant to make that change, right? They want that guarantee. And because at the end of the day, our lubricants are more expensive on a per liter basis compared to the conventional products. So in order to tackle that challenge, we have started offering energy performance contracts. So essentially the way it works is that we come in and we talk with your teams about the applications we want to look at. We define all the variables and we set a target on the energy savings. In the beginning of the project, you pay a base price, which is similar to the conventional oil that you are using. And at the end of the study, if we reach the target, then you pay the remainder over an installment period. If we don't reach the target, then you don't pay anything more. And you still get the advantages of using our lubricants that also provide better wear protection and longer oil life as well. The other nice thing is that if we exceed the target, because we're always conservative in what that target is, you actually get to have all of the additional savings, and that target is always fixed to a payback time of less than 2 years. So how can you get started? So the first is to select a lubrication partner, and it's important that they not only have the lubricants that can provide this energy savings, but they also have the know-how about your equipment and the expertise in the mining industry, and they have the OEM approvals. Once you've picked them, you have them come in and look at the entire plant to see where the biggest impact can be. We do the changeover, we run a pilot case on the first application, and then we start to look for more applications. And we think that the overall savings in the industry can be quite dramatic. Thank you for your time. Are there any questions? Great. Thank you very much.
Good morning, ladies and gentlemen. My name is Paulina Codoni. I'm the owner of Firma Codoni, and I have a great pleasure to make a presentation. The title of it, Making Processing Plants More Sustainable by Using Grinding Balls Made of Recycled Rail. First of all, a short introduction of my company. We are on the market from 1990, so more than 30 years. And we are specialized in production of forged steel balls that are used in processing plants in mines, in copper, zinc, lead, and rock ore extraction. We are focused on just one single product. Since 2006, we cooperate with many partners abroad. These first years of our existence were focused purely on Polish market. This was, among others, cooperation with KGHM, Polish copper company, and then from 2006 we started working in partners in Central and Eastern Europe. We are present there till now. 2 years ago, we started cooperation with also with partners in Scandinavia, in Norway precisely. What makes us different from other grinding balls producers? First of all, our basic and only material for production is scrap rail, so we don't use primary material. So this is the most ecological possible method of production. We also managed to implement innovative energy-saving solutions for production, and more than 40% of our staff are people with disabilities. Basically, we are a family created family-owned middle-sized company focused on just one product. Just to remind you very shortly about the grinding process, so this is a very crucial part of the processing plant process. Just before flotation, there are different kinds of mills, different kinds of installations, but usually ball mills are present there. There can be also rod mills. We don't produce rods, just balls. A short information about composition of grinding costs. So every grinding process that uses grinding media also has costs connected with lining and also the energy. And the distribution of these costs depends, of course, on what kind of ball it is, what kind of mill it is, but generally, as you can see on this draft, except from autonomous mills, in other cases, grinding media costs are quite significant, from 21% in SEC mills to 46% in secondary mills. Of course, this is on average. The question that the managers of processing plants always ask themselves, one of these questions is, how is it possible to purchase high quality and low cost grinding media? And we are sure that we found a solution for this problem. And this solution is using steel that is used, so using recycled reel, and adding to it innovative process of production. So, as I mentioned, the steel that we use, this is a recycled rail steel. This is one of our employers. He's working in the company for more than 30 years already, specialized in the first process of cutting the recycled rail. Just to remind you, this is how the rail looks like. The upper part we call the head of the rail, then there is another part, neck of the rail, and the foot of the rail. And for the moment, we our production is specialized on using head of the rail, which is 40% of the total mass of the rail, and in the next year we are already starting innovative new line that will be using also the other parts, so the neck and the foot of the rail. And this is how our process of production, very of course simplified version, looks like. This is the forging process. So in the first part, we separate parts of the rail just to have the head, the upper part. Then we heat it. We cut it into smaller pieces depending on the size of the balls that we are going to produce. We, in the same line, add more heating. Then we forge it with classical forging presses. Then it's this moment of cooling down to the temperature of quenching and quenching in water. And in this process of forging, we can achieve the diameters from 70 till 95. Basically, of course, we could also have other diameters, but these diameters are the most economical if we consider the shape of the rail and the diameter of the average rail. And also, starting from next year, we are starting production of smaller rails, smaller balls. This will be the balls of diameters between 30 and 40 millimeters, also made of recycled steel, of recycled rail, but this time we'll be using what we were not using till that moment, that is the neck or the foot of the rail. So if this goes well, and we are sure that it will. We already finished laboratory tests, and we are in the phase of assembling the line. We will be, I believe, the only company, to my best knowledge, around the world that recycles in a very efficient way whole scrap rail. The process first phase will be, of course, the same as of the first process. Of the forging process, we have to first separate parts of the rail to get separated long pieces of neck and foot. Then we will be warming it to the final temperature. It will be just one moment of warming, of heating. Then there will be the first rolling process. During this process, we will achieve rods. So this will be a very innovative process because it will make parts that are flat and irregular into perfect round shape. Without bending it, but just squeezing and rolling. Then these rods will pass to the second rolling section, and the process of balls rolling will happen there. And then similarly to the first process, cooling down to the temperature of quenching and quenching. And thanks to implementation of this process, we'll be able to produce smaller diameters of balls, that is from 30 till 50. The demand for them on the market is very high, and till that moment they are only produced from primary material. This will be for the first time that they will be used from scrap rail, from any scrap material. Benefits of this process: first of all, very short production cycle. We believe to be a part of the circular economy. We made a very big shortcut in this sense that normally scrap rail needs to be completely melted and turn into rod, and then this rod out of this rod the balls are produced, and we made this shortcut that we do it straight from the rail itself. We don't need any preparation, so all this cycle is much shorter. in terms of time, in terms of also much lower energy consumption and limited CO2. We basically don't need to melt it completely, we just heat it to the temperatures that we calculated, and as a consequence there is a great optimization of heating. Of course, this involves lower costs compared to alternative technologies. Our products also in the process, thanks to this innovative process, have perfectly regular shape that is needed for grinding. They have homogeneous quality because they are always made from the same very high quality material, and also we managed to achieve high homogeneity of hardness of our balls. Just a few graphs to present you the hardness of our balls. These are the blue lines. We took 3 samples of our balls, blue lines, and of our competitors. So depending on the this 0.038, this is the core of the ball. For our competitors, for us, this is, as you can see, somewhere around 50. And we checked the balls that we produced in we checked them in laboratory, and also we took other balls that are produced out of primary material that are on the market, because of course they could have better results also, but we took the ones that are most often used on the market. This is a similar graph for size 40. Also ours are the lines that are blue, and competition is yellow and green. And number 60, here we had just 2 balls for tests. Just a short information where we sell our balls for the moment. So these are, as I mentioned, we started from Poland, then started covering other countries of Central and Eastern Europe. We are mostly present at the moment in the Balkan states and also in Norway. Just before COVID, 3 years ago, we participated in MindTech business competition in Kazakhstan, where we competed with quite a lot of companies presenting their innovative solutions that are used in mines, and we got the first prize for presenting of this technology. The commission decided that our solution is in fact very simple one, but very innovative. They appreciated the ecological aspects of it, these aspects connected with sustainable development. Thank you very much for your attention.
So, welcome everybody in Exhibitor Innovation Forum. My name is Filip Sławczew. I represent the Polish company Glinik Drilling Tools. We are the manufacturer of mainly rock bits suitable for all kind of drilling applications. Today, subject of presentation gonna be innovative hard facing on drilling rock bits done by laser cladding with abrasion-resistant materials. So nowadays the professional mining and mineral sector requires to have extremely efficient and robust tools with extended product life to be sure that we will be able to avoid any borehole failures and also to make a drilling job more cost effective. That's why Glinik, as an experienced and successful producer of drilling tools, since 2019 is developing the technology of putting the hard facing on rock bits using the LMD, laser metal deposition method, which we can refer to 3D printing. At this point, we are using it in our production line for large diameter bits and other tools with a large diameter. And in the future, we would like to put it also in our hole openers and small diameter mining bits. I mentioned the Glinik as an experienced manufacturer. Experienced because since 1883 we take a biggest care about the highest quality of engineering solutions and constant product development. We have almost 140 years of traditions and story and experience, which we are proud to present. In result of this experience, we can offer to our customers professional drilling tools with cutting-edge technologies and the product which is made in a state of the art. So let me tell you a few words about the laser robot which we use for our technology. Here we can see how it's constructed. I mean, the main part is a high-power fiber laser from IPG Photonics brand, which is connected with the high-class process head from a Precitex company. Those two parts are the fundament of this prototype automated laser station. It's based on a system of a 6-axis arm and additionally with the 2-axis positioner. The 3D printing technology is used mainly for hard facing the difficult geometrical shapes of a hard facing on drill bit cones and shear tail protection. Here at this short movie we will be able to see how it's operating exactly, and so we can see that the large diameter cone of a bit at this point, and how this process can be repeated in a exactly same way every single time, and how complicated geometry we can put by this robot. So how it works in generally. This technology uses a high power laser beam focused on a very small area. It's basically the process of melting the special powder material by using the energy of a laser radiation and with the shield of a protective gas. So both materials are melted by the laser beam and they are creating a padding weld on the surface of the base material. In this process, we can build the structure layer by layer directly on the surface of hard-faced elements. This process, besides of the drilling industry, has application on the also in aerospace, energy, petrochemical, automotive, and even in medical industry. So what is the main objective to why we use it? Of course, for the manufacturer, most important is to make their manufacturing plant most cost effective as it's possible, and we achieve this cost of efficiency by especially making the process much shorter, much more accurate, and we can repeat it as mentioned in the same way every single time. So the whole process is getting more reliable. At the end of the day, we also achieve the much higher process clarity. So as you can see, this technology gives us a lot of profits, but it's obviously it's still on developing process. We started it in 2019. We plan to finish this project at the end of this year. At this moment, why I haven't mentioned a lot about the powder material, because the patent is still pending. So we're still trying to understand how the process is working, how the structures are working together, what are the connections between one and the other materials. But the engineering team, what you can see on the picture, is continuously hard working on it. Some words about how we prove the results of if this material is working or not. So we provided the tribological test carried out in the laboratory to first of all to determine the abrasion resistance, which we compared to the classic Hardox 450 steel, and the mass loss after the test was really small. Like so we can see that our material is around 164 times more resistant to abrasive than the classic Hardox steel. The other test was testing of resistance to impact loads, what we provided with our patented laboratory stand, and we can compare it to heating the material by 20 kilo tools for 5, 10 and 20 times, where the total impact energy was about 200 joules. And even after 20 strokes, we can see only the small damage of the material. So, as mentioned, Glinic is constantly working on implementation this technology, and not only this technologies. The rock bits and the drilling materials seems to be the simple tools which cannot be more developed because they are working like since over 100 years. But our method of working is to looking for a still more efficient and more reliable tools and solutions for our customers, which is the crucial approach of our company at this moment. So, for a better understanding the process, I can invite you to ask more questions, to discuss more about the drilling tools, about the drilling industry, to our booth number 262, which we provide together with the Polish Investments and Trade Agency. So you're please feel invited to visit us and talk more. Thank you a lot.
Good morning. My name is Jolanta Smentek. I represent Capital Group FASING PLC, located in Poland. Let me introduce FASING Group as the leader in providing comprehensive solutions for underground mining. Our effective business model consists of some production plants, FASING company located in Poland, MOI PLC as the company also located in Katowice in southern part of Poland, forging plant, Konko company, Becker printer company located in Germany. Also some our subsidiaries company located abroad, FASING China, FASING America, FASING Ukraine, and FASING Schwarz located in Germany. As the comprehensive solution for mining industry, we could provide mainly chains intended for chain conveyors, round link chain, flat link chain, many kinds of connecting links, drilling machines, couplings, as well as mechanized supports, as well as pawns offered by Konko company. Regarding the sectors we provide with our products, so mainly there is mining industry, also lifting and transportation sector, fishing sector, energy sector, automotive industry, hydraulics industry, railway industry, water supply industry, and shipbuilding. We also offer our products for agriculture. Some basic information on the history of our group. FASING company was established in 1913. Then through the years we create a lot of new subsidiaries companies with modern products for many industry branches. We provide our products worldwide. Our products are used by more than 4,000 users in 49 countries all over the world. Regarding the offer of our company, so as I said, so main product are the mining chains, both round link and flat link chains for underground mining, but also some chains for other application. As I said, used mainly in fishing industry, power industry sector, and some other general application when the chain could be used in chain conveyors. In our offer, there is also the wide range of flight boards, connecting links, also chains for hoist and transport purposes, and chains for fishing industry and general accessories for this branch. Our machine park are still modernized, and our new investment, so it was a welding machine which is at present used at our company to manufacture 60 millimeter chain at our facility. Regarding our subsidiary company, it is MOI PLC. So there are main products like couplings, drilling machines, roof bolting machines, aggregates, and support legs. The main offer which we could provide regarding the products of MOI PLC, so it is construction and technology department, service and repair services. Within MOI PLC we have the forge plant. We are able to forge the hot die forgings, the weight in the range starting from 10 grams till 25 kilograms. Different forging tools, cold and hot calibration of forgings is offered. Also, thermal and mechanical treatment on forgings is available. Also, simulation of forging, optimal shape selection and forging processes. Forgings are manufactured according to customers' technical documentations or product samples. MOI PLC supplies their products worldwide to many countries all over the world. Regarding our new products, so we are proud of big diameters chains starting from 38 millimeter, and at present our new chain it is 60 millimeter chain, which we offer for Australia, USA, and Chinese market. We are proud of our master profile double cladding chain with the wide range of diameters, also wide range of our connecting links. FASING is certified with ISO 9001 and 14001. So we have both assurance system for quality and environment. Regarding the awards, so we are the winner of many awards for innovative products, and we are proud that within many years we are the winner of the awards, not only in Poland but also abroad. Our strategic partner, Konko company, is the manufacturer of the steel construction. There is the mid-sized company which provides complex services of steel construction, fabrication to customer, require high quality of machining and welding based of the client's documentations. The benefit, which is from the decades of the experience of Konko company serving mainly mining and steelmaking industries, but also other branches, believing that the most important who have appropriate competence and knowledge to meet the highest needs of the customers. Projects which are made within the Konko company, so there are the wide range of different products starting from pens, steel plates, canopies, crushers, stage loaders, mechanical supports, as well as different sort of pens. Konko company is also to provide containers, loader frames, loader arms, work platforms, compressors, casings, elements of the cleaning stations, also offshore constructions, and exhaust ducts. Thank you very much, and you are very kind welcome to get more information at our booth number 262. Thank you very much.
time to start this presentation, New Steels for the Mining Sector. My name is Jan Eckelid, and I'm Technical Development Manager at SSAB Special Steels, responsible for Northern Sweden and Norway. And together with me, I have Jonas Allebert. Jonas is wear specialist, working at Knowledge Service Center, supporting customers in wear situations or wear problems. Before I hand over to Jonas to talk about two of our new steel grades, I would like to say that we offer more than just steel. An important part is, of course, different kind of commercial services, but also technical support, where we have a lot of focus trying to understand the customer's problems and also to support how to choose the right materials. We have technical support managers in a worldwide organization responsible for different markets. Then we have Knowledge Service Center having responsibility for different technical areas supporting customers worldwide. So if you have a technical problem, please don't hesitate to contact SSAB. You find contact information on our webpage and can be directed to the right person. All right, let's talk about the products that could be of interest to the mining sector. So please, Jonas, go on.
Thank you, Jan, for the introduction. So I will start with introducing the new product for wear-resistant steel within mining industry, Hardox 500 Tough. And this is the next wear steel that can be used as a general wear plate. Before we have been using Hardox 450 as a general wear plate. It can be used in structured wear applications and has good workshop properties and mechanical properties. But a few years ago we launched this new product, Hardox 500 Tough. And if we look at some basic properties of this material, it's a further development of Hardox 500, and it's the next step after Hardox 450 as a general wear plate within mining industry. And today we can produce this material from 3 mm up to 25.4 mm, and that's 1 inch thick. We launched this product 2017, and before that we have been during almost 10 years of development time to be able to produce this material with these properties. If we look a little bit on mechanical properties of this material and compare it to Hardox 450 and Hardox 500, first of all, what you can see is that we have a much more narrower hardness interval when it comes to this product. For Hardox 450 example, we have from 425 up to 475 when it comes to hardness interval. For Hardox 500 Tough, we have only plus minus 15 Brunel. So it's from 475 up to 505, but we aim for 490 Brunel. And this is of course a very good thing when it comes to forming of plate and also when it comes to predicting service life within the mining industry. The tighter the hardness interval, the more predictable the maintenance intervals would be, but also when it comes to formability of the material, when it comes to spring back and so on. It would be much better with this tighter hardness interval. When it comes to toughness of the material, you can see here that we are almost on the same level as a Hardox 450 when it comes to toughness. A typical toughness is 45 joules at minus 40 degrees Celsius. and Hardox 450 has a typical one of 50 joules at minus 40 degrees Celsius. But what we also do on this product that we're not doing on Hardox 450 and Hardox 500 is that we give you a guaranteed toughness, and that is minimum 27 joules at minus 20 degrees Celsius. So that is what we guarantee on all the material that we deliver to our customers. It will not be worse than 27 joules at minus 20 degrees Celsius. But as you see here, a typical toughness is more of a 45 joules at minus 40 degrees Celsius. So it's an extremely tough material as well. Some workshop properties. The aim for this product was to keep the good workshop properties that we had on Hardox 450, but move up to 500 Brunel level instead. So when it comes to weldability of the material, there is no preheating demand or special requirements when it comes to consumable or something for 60 millimeter and thinner material. If you're using a thicker material than 60 millimeter, we have a preheating recommendations of 75 degrees Celsius, and that is not too high. When it comes to formability of the material, we have the same recommendations as a Hardox 450. So that means that you don't need to change anything when it comes to minimum radiuses and so on. If you're using Hardox 450, you can use it exactly the same as a Hardox 450. The only thing that is changing a little bit when it comes to forming is that you require a little bit higher forces in the bending machine, and the material will have a little bit higher spring back, of course, but that is related to the hardness and tensile strength and so on of the material. On the other hand, if you're changing from Hardox 450 to 500 tough and reduce the thickness a little bit, you can actually reduce the forces in the bending machine instead. At SSAB we have our own wear testing machine to be able to test the wear resistance of our steel grades. And the reason for this is that we are trying to do wear testing that is very close related to raw material handling, like mining industry, quarries and other type of situations. And we see that the standardized testing is not close to what is going on in a bucket or in a mining truck or whatever it is. So we have designed our own wear testing machine, and that is a drum machine that is approximately 800 millimeter in diameter. And inside this drum we can fit 34 different samples of different steel grades, all the Hardox grades, mild steel and other type of material as well. And then we fill this drum with abrasive material. It can be copper ore from a copper mine, or iron ore from an iron ore mine, or granite rock, or whatever it is, crushed glass or something else. And then we run this machine for approximately 90 hours, like a week, more or less. We are changing the abrasive material 2 times per day to get a fresh abrasive material. And all the material will slide on the bottom of this drum and cause sliding wear on all the samples. And the good thing with this is that all the 34 samples will have the same conditions with the same abrasive material. And it will be a big difference depending on what abrasive material you are using. A copper ore doesn't have the same relation between the wear resistance material as an iron ore. And then we are measuring the weight loss of each sample after this 90 hours of running. And the weight loss is recalculated to relative service life, because what you want to know is how much better is one material compared to another material. So if we look at one example here of for a granite, 16 to 25 millimeter granite, and compare it to Hardox 400. So we have Hardox 400 as a relative service life 1. It can be 1 year, 1 month, 7 years, or 1 hour or something. And then we can see with this wear test that Hardox 450 is 50% better than the Hardox 400. And the Hardox 500 Tough is 80% better than the Hardox 400 for a granite. If we would have tested iron ore or copper ore or something else, we would have a little bit different results. But for a granite, we typically see 80% increased service life. We have done a lot of wear testing within this drum machine, and also we have literature study on wear and so on, and we have created a tool, a software tool that is able for all our customers to use, and just go in on ssab.com and use this program. And with this program you can actually calculate for different abrasive materials the relative service life for all the Hardox grades. So there you can actually choose granite, or you can choose iron ore, or you can compose your own rock with your own mineral analysis and see the potential for the different Hardox grades. So this is possible to download for all our customers. And if we use this example here for a copper ore, a typical copper ore, we can see that moving up from 400 to 500 tough, you will have approximately 85 to double the service life. And from 450 to 500 tough, you will reach approximately 35 to 40% increased service life. And these numbers we can use in an example. So if we look at the mining truck, the liner plates or the bottom floor of a mining truck, it can be a liner plate or it can be the floor plate. So if you are using a 25 millimeter of Hardox 450 today as at the bottom plate, and with this program you can see that Hardox 500 tough is approximately 35 to 40% longer, and that means that you can reduce the thickness with 5 millimeter, and instead of using 25 millimeter Hardox 450 you can use 20 millimeter of Hardox 500 tough. And the good thing with this is that for the mining people, they will save weight on the mining truck, approximately 2.3 tons for a typical mining truck. And of course, this will give fuel savings when it comes to the lower weight. So approximately 10,800 liters per year for a mining truck, with just reducing 2.3 tons of the mining truck, because that is quite difficult, because you have a bucket that is loading as much as possible in the mining truck with four passes or 5 passes or something like that. But the weight savings will always be there by reducing the plate thickness and keeping the same service life. But it's also good news for the tray producer, the mining truck producer, because they will, first of all, they will order 20% less material. But they can also, when they install the liner package or when they are building the mining truck, they can actually increase the welding speed, because welding a thinner plate goes much faster than welding a thicker plate. And of course this generates less welding consumable when it comes to installing the liner package or building the floor of the mining tray. We have also a machine in SSAB to be able to test dent resistance of our material. So it's a drop hammer rig where we can drop heavy weights on a steel sample or a steel surface actually. So the sample size in this case is approximately 1 meter times 1 meter, and then we are dropping heavy weights up to 400 kilograms from 2.7 meters height on the plate surface, and then we are measuring the dents that is caused by this on different plate thicknesses and different grades. And what we can see is that there is a quite significant difference between Hardox 450 and Hardox 500 tough, and that is related to the yield strength of the materials, the difference there. And especially when moving down to a little bit thinner, when you have maybe 20 or 25 millimeter, you will not see a big difference when it comes to dent resistance, but when we are down at 12 millimeter, you will have a significant difference between Hardox 450 and 500 tough in dents. And for a liner package, maybe you are using 20 millimeter in the floor plate, but after some years you will actually have 12 millimeter in the liner package due to wear. And there you can see the difference when the dents starts to happen, that the 500 tough would be a much better material compared to 450. So if we summarize Hardox 500 tough, this is the new wear steel for mining industry. we have the same formability as Hardox 450. We have a much tighter hardness interval compared to our other steels and all the other steels on the market. We have a guaranteed impact toughness. We have a typical toughness of 45 joules at minus 40 degrees Celsius. No preheating for 60 millimeter and below. Thickness is from 3 millimeter up to 25.4. We are making it possible to reduce the weight or prolong the service life or increase the payload of the equipment in the mining industry. I also would like to take the chance to introduce another new steel that we released 2 years ago, and that is Hardox High-Ace. And this is a material that can be used in wear corrosive environment, where you have corrosion problem together with wear. So what we did when we designed this product was that we took the best from stainless steel and we took the best from Hardox, and we created this material as a wear resistant steel with corrosion resistance in the material. If we look a little bit on the product, we can produce this material from 3 millimeter up to 25.4. Hardness is 450 Brinell, so it's exactly the same as a Hardox 450. We have a toughness guarantee on this product as well, 27 joules at minus 20 degrees Celsius. And of course we have a data sheet. And in this case there is no good standardized wear testing for doing testing on wear corrosion. So what we did here was that we were using our drum machine again, and I have one example here of copper concentrate. So what I did was that I took in copper concentrate and I put that in the drum machine, and then I run it for 3 weeks more or less. And I had included some water together with the copper concentrate, and we were measuring the pH level of this copper concentrate during the testing, and we could see that the pH level was between 4.9 up to 6.5, so it was a little bit acid. And we measured the weight loss and recalculated that to relative service life, and the result was quite amazing actually. And if you compare it to Hardox 400 as a relative service life 1, you can actually see that Hardox High-Ace was almost 5 times better than the Hardox 400 for the copper concentrate. And this is of course very good news for people that is transporting or handling copper concentrate. And I believe that in this case it's not only due to the low pH of the copper concentrate. I think it's a matter of also galvanic corrosion, because if you look at the electrochemical series, you can see that copper is more noble than iron and than steel, and that means that we will have a galvanic cell that is actually increasing the corrosion even more when it comes to corrosion. So this can also be one thing that is causing extra weight loss. So I think there is a great opportunity for Hardox High-Ace to be used for copper concentrate handling. But of course we have been testing other things as well, like manure handling, garbage handling for garbage trucks, and wood and bark handling for the pulp and paper industry, and so on. And we will keep doing more tests to understand where we can use Hardox High-Ace in a good way. Some reference cases when it comes to Hardox High-Ace in copper concentrate industry. We have a tipper manufacturer in South America that is building tippers for transportation of copper concentrate. They have already started to build these tippers in Hardox High-Ace with good results so far. We also have a reclaimer bucket that is made of Hardox High-Ace that is handling copper concentrate in South America, and they are very happy so far with the with the results and performance of hot high-ace in this type of environment. But I think there is a lot of more opportunities and areas in the mining industry where we can actually benefit from this hot high-ace that is more corrosive resistant than other hot grades. And by that, I will leave the word to Jan again.
Thank you, Jonas. Now I would like to talk about fossil-free steels. You will have the possibility to buy these two steel grades Jonas have been talking about, but also all other steel grades from SSAB as fossils-free within a couple of years. This was actually started as a project at SSAB 2017. The project company is called Hybrid, and that is actually short for Hydrogen and Breakthrough Iron Making Technology. And it's SSAB together with the mining company LKAB, but also electricity provider Vattenfall that owns this company Hybrid. First, why are we actually doing this? Maybe obvious for most of you, but as we are aware, we have something called global warming, and the main cause of that is carbon dioxide released from fossil fuels. And the steel industry itself accounts for approximately 7% of the global CO2 emissions, which means that it's quite important to make some improvements in this industry. You could actually ask yourself, is steel a dirty material when it comes to emissions? And that is actually not true. So if you compare different materials, how much carbon dioxide they emit per ton produced materials, you can see that steel is quite an efficient material. The problem here is that the volume of steel, it's far the biggest volume used as construction and the most important engineering material in our lives. Also quite important to discuss is, of course, what can we do already now? You can use better steel. Different steel mills have different emissions per produced ton of steel. And SSAB is actually already today a very efficient steel mill. Even more important is to use a better steel. By using a harder steel or a stronger steel, you could actually use less steel to do the same work. So that is something that end users could do already today, upgrading, using a better steel to reduce the emissions. But I mean, as a final step, going totally fossil-free, that is the biggest step that is to be taken. And we aim to be first to offer fossil-free steel products in the market. Talking about recycling, which also is an important part of making better or less emitting steels. Steel is the most circular material among all materials. Actually, 100% of the material could be recycled, and you could recycle it over and over again, making premium products, high quality products. The recycling rate today is around 85% worldwide. So then you could ask yourself, could it be enough just to produce steels by recycling, or is it really needed to make steels from virgin material? And if you look upon this estimation, you can see that the volume of steel will grow for the future. And because of that, we will need today, but also in the future, steels produced from iron ore. and that is where we focus to produce fossil-free steels. And our plan is to introduce fossil-free steels on a larger scale in the market 2026. And previously we have said that the whole operation, SSAB operation, plan to go fossil-free 2045. But we have actually announced now that we will speed up this process, and there is a possibility to go fossil-free already 10-15 years ahead of 45. To do this, we need to do a lot of investments that is actually already going on in the different mills. But as a plan, we need to build, or we plan to build, actually two mini mills to produce strip materials. One will be built in Luleå and one in Rae. And they will have the capacity to run fossil-free sponge iron and also recycled scrap. The plan is to produce something like 2.5 million tons each in these two mills. And right now we are planning for exactly which are the technical capacity of the different lines. And we plan to interview important customers to make the best out of these two investments. Then there is of course also a need to build like a factory to make this fossil-free sponge iron. And that plant will be ready 2026, and the capacity will be to produce 1.3 million tons of fossil-free sponge iron, with the possibility to expand the production up to 2.7 million tons 2030. And that plant will be built in Gällivare, some 300 kilometers north from here. And this plant is of course crucial in order to start the deliveries of more materials. Already today we have a test facility in Luleå that can produce small amounts of fossil-free sponge iron. And by using that material, we actually already have some small production of commercial products in the market. As an example, Volvo have already produced and delivered an articulated hauler in Sweden, and Volvo Trucks is actually planning to have production of a electrical truck available starting from Q3 2022. And now some technical details. How is it then possible to make iron ore based steel fossil free? Since long there are actually two known ways to make steels from iron ore. The most common way is to use a blast furnace, the route to the left. And what you need to do is that you want to get rid of the oxygen in the iron ore. And by adding coal, you produce carbon dioxide, and that is the main contribution to the emissions. But there is another known route. Instead of using coal, you could use natural gas. And there are a few mills available worldwide that is using natural gas. The problem is that natural gas is not fossil free. But using the same process, instead using hydrogen, you will produce water when you reduce the iron ore from the oxygen. So you actually first produce hydrogen, then the hydrogen is reacted with the iron ore and you produce water. And in order to produce hydrogen you need a lot of electricity, green electricity. So this is actually the process that we are going to use to produce our steels. And looking into the energy balance, to the left you see the blast furnace. You need a lot of coal, and you create a lot of carbon dioxide. And to the right you see the difference, and the main takeaway here is the need of electricity that is needed, and that is actually the reason why electricity provider Vattenfall is part of this project, because they will be responsible to deliver the fossil-free electricity to make the hydrogen. By combining LKAB's fossil-free mining and the fossil-free electricity from Vattenfall together with our steel production of fossil-free steels, we will have the capacity then to deliver fossil-free products to your operations, and by that you will have the possibility to take part of this value chain, and you have the possibility to offer fossil-free products to your customers. Then maybe the most interesting question for a tech guy like me is, what about the steel properties? Will the steel properties be different from today when it comes to welding, bending, all kind of forming operations and so on? Actually, the mechanical properties of the steels are created in the downstream process by heating, quenching and so on. And that process will not be different from today. So the properties of the steel will more or less be the same compared to today. And we will have the possibility to make all existing steel grades that we are producing today also as fossil-free. And depending on the customer need, we will select which steel to start with and so on. But the basic message here is that all steels could be produced as fossil-free, which should be very interesting for you as customers. You have an example here to the figure to the bottom left. That is one of the few produced fossil-free steel plates, and if you have good eyes you can see that it's actually marked fossil-free, and that will probably be the case also for the produced materials in the future. By that we have finalized the presentation. If there are any questions, it is possible to raise them now, or you have the possibility to contact us via ssab.com on internet. You can send in a technical question, and that question goes to the local technical support that will be responsible to contact you and give you a proper answer. And we are happy to support in any kind of technical development project, or just answer if you have any steel-related technical questions. So by that, we close the presentation. Thank you for listening.
Good afternoon. Welcome to my talk, Changes in the Delivery of Mining Capital Projects from a Mining Contractor's Perspective. My name is Patrick Hudd and I work for Cementation Americas. The keywords for this talk is capital projects, contracting, logistics, safety, training, risk, optimization and project delivery. We'll quickly go through why would we even contract the work. It's a legitimate question. Also, how do we have the ability to influence successful outcomes for mining capital projects? A little bit on procurement and commercial strategy, risk, typical contingency criteria, partnering, the collaboration philosophy for partnering, operations readiness, the resources, labor, material, digital infrastructure, the connected mine with short interval controls and management systems, and then just to summarize the pathway to success. So why should you contract the work? Well, contractors are normally engaged because they have the ability to provide a service that the client or contractor does not wish to perform or is not able to perform, or it's not viable for them in the medium to long term. But contractors, like everyone else, are in business to make money. And there's the old ways of contracting that many of us are familiar with versus the new current trends where there's much more engagement and leadership in the technical, commercial, inclusion and diversity, and of course the safety culture. We see contractors, especially ourselves, Cementation, taking on wider scopes, especially with leading across the whole project life cycle and the breadth of the project scope. We often lean into design-build jobs and are ever more focused on lean strategies. We're more sophisticated than ever. In general, the ability to influence a capital project occurs first in the early stages of the project. If we think about a mining development contract, specifically a shaft, everyone always talks about the shaft advance rate. This is maybe a third of the total overall project, and so much time can be squandered with the engineering phases as well as later on phases such as commissioning and startup. But it's the shaft advance that everyone focuses on. We like to get involved at the engineering and study phase of projects from the concept and pre-feas and feasibility, as we feel that's the best way to bring our knowledge to your project. It also means that we're not fighting against the stream for a decision that's already been made, and the best ideas can be introduced at the start. This doesn't mean that our ideas are the best, it just means that all the ideas, when they're on the table before they get more solidified into a path of action. We also, with the engineering that we offer, is quite unusual for a contractor, and we feel this gives an advantage for sole point accountability throughout the whole life of the project, removing some of the extra interfaces that can occur. The procurement and commercial strategy is key. Later on, I'll talk a little bit about some of the target and partnering style contracting strategies. There's lots of examples here, from traditional target price variations through fixed fee, the target schedule performance index and cost performance index model, to different key performance indexes and hybrids. It's important to note, though, that if you haven't been on the contractor side of the equation, we have our internal due diligence and our corporate governance that we have to comply with, just the same as the procurement side on the owner's sides. We have to do motivation documents, lessons learned, contracting principles to get sign-off from our board and to get a negotiation strategy for what we can engage with the clients for. It's the same, but often overlooked. When we talk about the target price models, the fixed fee doesn't really incentivize contractors too much. Their maximum profit is capped. Their incentive is to not expend costs so that they get a higher profit to revenue rate. However, the better models are the SPI and CPI models, as they allow for the incentive to be carried throughout the project. Our favorite is the reimbursable KPI model, as it allows us to engage with less defined scope and engage with our partner to move ahead, and the key performance indexes, the KPIs, can be changed according to the phase of the project for what's of interest to the client. risk and opportunities. It's important to remember the opportunities. That's the flip side of the risk. As you can see, the contractor's risk goes up depending on the contracting strategy as you move away from cost reimbursable down to lump sum. Traditionally, much mine contracting was done on unit price. However, we're seeing less and less of that now as clients want to obtain the maximum economic benefit that they can. Target cost allows it to be the most equitable as it gives room for the fee and the profit to be shared, but also the risk to be shared, so the gains and pains. The contingency criteria is important. As I say, we often get involved in study phases. What this means is that there's the management reserve, contingency, whatever you want to call it, that gets applied to the project. Sometimes, though, this is quite arbitrary how it's assigned and will vary from organization to organization. It really becomes a matter of, do you want the red pill or the blue pill? We prefer the more subjective approach based on levels of quotations, classifying the estimates, are they first principles or parametric? Only then, when you properly understand the cost, can you then properly understand and apply the contingency and also allocate it, much like risk, that it's in the best place for where it can be managed and who can gain the most to control from it. I don't mean controlling the contractor or controlling the client. I mean controlling the risk. Then you should be the person that carries that risk, as you are the best position to control the outcomes. Partnering. The contract doesn't have to be written in blood. In fact, we evermore try not to even refer to the contract, but to refer to it as an agreement. It's more of a cultural alignment between the parties. If you choose partnering, you're choosing that all groups within your parties are aligned. This is really important for the effective partnership. We have seen before on projects where an executive for the client might be very keen on partnering, but the procurement group are not aligned with that and try to revert to the lowest capital cost or whatever their own marching orders might be. For partnering to work, all tiers of the organizations on both sides of the partnership need to be aligned for the approach to get the best outcome. The advantages that this brings is that everyone is aligned. You're working towards a common goal, and most importantly, you're reducing conflict. Conflict isn't just about fighting over claims. It also destroys the morale and the trust and the ability to be flexible as the project changes. And we all know that in mining, the ground is the key thing that we're developing through, and that's what changes. We have to be open to the changes. With our processes and fundamental agreements, we need to be ready to move. When you commit to the collaboration philosophy, it is a culture and it is quite difficult for some organizations. It does sometimes take facilitated workshops and, like I say, all tiers of the groups that might need some feedback and redirecting coming back if they're not fully engaged in the process. However, when it does work well, the contractor is part of the owner's project team such that they look like they're wearing the same coveralls or hard hats. Everyone's working towards the same goal, and there's no differentiation between the different service providers. With the goals being the same, it means that you can commit to manage and measure the performance openly and to the common goals, rather than against what your agenda might be. This also enables you to focus on continuous improvement and the performance management. And it's important to note that just having a project controls group won't do anything for the project unless you are committed to using that data and having the performance management fall out from it. The trust that comes from the partnering enables you to implement the contractor's best ideas. I can tell you right now that when it's a competitive bid situation, owners and consultants sometimes think they're going to get the best contractor's ideas, but people will be quite cagey and save their ideas for when they're shortlisted or later on in the process. When you pre-qualify or select from whatever criteria your contractor as early as you can and integrate them into the team, there's an area of trust that develops and expands, and all the ideas are shared. Nothing ends up being held back. As I said at the start, contractors are in business to make money. We want to make a reasonable profit. We don't need a contracting mechanism that enables us to make excessive profits, because we want the repeat business as well. We want the projects not to overrun and be a successful outcome for everybody. It's also important that the decisions need to be based on the project, not on the individual parties, and this can only happen when you're truly partnering. The commercial approach, we've worked with clients a lot, but some of the key things are to make sure that the incentives are right for the goals that you're trying to achieve, that the risk, as I mentioned earlier, is correctly allocated, that it's transparent. You don't need to hide behind a contract or understanding of the legalese that might be applied later. It's also important to have the best scope definition possible, and potentially to identify areas with less defined scope that we can make sure are treated differently in the agreement for later scope definition. It needs to be easily understood, simple, and able to be worked. You do not need trailers on site of people pushing the project bureaucracy. You need people to be effective, gathering and using the data that enables you to make good decisions. Also, the costs need to be classified, whether they're base costs, whether they're risk, with criteria for scopes, delays, and risks, and what-if scenarios developed before they occur. This is good as part of the risk management process to identify risks, but it also works very well to make sure that you're reducing conflict, because it's already pre-agreed what that scenario would trigger. Again, this leads into the non-adversarial dispute resolution. It should be part of the charter for the partnering agreement. Operations readiness is very important for a successful project. This is because there's a lot of pressure for the project to be starting and getting underway. People always want to break ground or move gear onto the project. It's important to do pre-start audits to make sure that the project is ready to go, to be successful, to be safe. It's also important for the operations readiness side that when the capital project is finished, the facility is ready to be handed over and operated as it's expected. Of course, the resources that are going to be used for the capital project are key, and there's nothing more important than labor. We've done a lot of work with new miner training programs for indigenous peoples in the far north in Canada. We also apply it as global best practices training for upskilling or performance improvements for labor in established mining jurisdictions that might be wanting to apply new cultures or skills. In general, the new miner training program will take a off-the-street person with classroom-based training for a period of weeks, followed by underground awareness training, and then an entry-level coached and mentored position. We've had a lot of success doing this. The other resources, of course, materials. We are now getting ever more sophisticated materials and logistics management, including operating the entire materials management for clients on their capital projects. This is a big difference from before, when the contractor was seeking free issue of materials, and the ownership that we give allows it to be more credible that the materials are being controlled. The connected projects are ever more technological. We're seeing this with monitoring underground, cameras, and all the data collection. It allows us to identify problems early and mitigate them. It also allows us to do the integrated short interval controls, which enables us to look at all the key elements within the project cycle for the development cycle and see what's working, what isn't, and even the things that are working, how can they be improved. That's an example of how we apply the management operating system using the short interval control. It has open discussions, every 24-hour deliverables, and it's discussed with the crews. It's nice to see the technological graphs, but here you can see it's also quite low tech. It's handwritten on the boards in the meeting rooms for the crews, because it's important to get the end users buy-in. Much as you see with Lean, it isn't top down, it's bottom up for the people doing the work, explaining how they can do the work better, and then listening to them and using those changes. When we do apply the lean systems, we have, again, a board with a lean strip. And the key takeaways here are there's an initial fix to the problem, but then the problem isn't just assumed fixed. It's then noted and carried out for a more permanent, proper fix for longer term, and it's also status, so we can see how it's going. In general, it's a pretty simple pathway to project success from the contractor's viewpoint. You have to define the cost base, you have to have a realistic budget and schedule that hasn't been pushed by any other criteria, so the partners are able to develop it jointly and develop it for what they feel it will take. This means the best scope definition, it gives you the best opportunity for cost reduction, and if you're open book, it's all auditable. The markups are agreed, and they're agreed to be reasonable, so everyone can make a profit, and there's opportunities for any extra work as well. If you go with the final target price approach, you get the best methods, you use the best equipment, you have realistic performances, which may be able to be surpassed, but they're realistic for the steady state performances, and you've had operational input. The risks and delays, you can expect to encounter risks and delays on projects. It's how you deal with them and handle them that counts. The actual project performance, you can, using the short interval controls, always be improving it, even if you're already beating what the target says. There's no reason not to. And then at the end, the project outcome, you've met the project goals. You've achieved zero harm. You're below the target price, ahead of the schedule, with no rework. And all those lessons learned should be carried through to the other projects that are underway, as well as the estimating team. Thank you for your attention.
Good afternoon, ladies and gentlemen. I'm Esko Tahkola from Sidra Minerals Processing, and I'm here to talk about how to maximize the net metal production in concentrators with novel particle size measurement technology by Sidra. The basic dilemma on current market situation is that how to maximize the net metal production and profitability in a situation where the ore grades are falling, operational costs are increasing because of energy, manpower, water and environmental costs. And there is no time to invest on production facilities because those investments take years to fulfill the payback. It is well known that with increasing the particle size, you can increase the throughput in the mines. But how to do that in a controlled way so that you are not risking losses via losses in recovery? There's the solution for that. The conventional technology to control the particle sizes is to have analyzers that take samples from the consolidated hydrocyclone battery overflow line. That sampling is not very representative. It is not providing a real-time measurement response, and these devices will need a lot of maintenance and also recalibrations. In addition to those ones, people are using technologies that are monitoring the equipment itself, so the hydrocyclone battery. And there are roping detectors based on various principles. Instead of monitoring the equipment, which is a cost factor for a producer, Sidra has produced a measurement system that measures directly in real time from every hydrocyclone overflow the particle size that is produced for flotation. And based on that, you can optimize the grinding device circuit as a total. The measurement is based simply on a principle of placing a waveguide into the overflow pipe where the particles hit. And the impact is generating an acoustic wave, and that is then that acoustic spectra generated by the particle sizes is then calibrated into particle size. Only once that kind of calibration is then needed to be done. The features and primary benefits of these ones are that you can follow up 5 different particle size limits with a response time of 4 seconds from every hydrocyclone overflow. You can reduce that particle size variability that goes to this flotation stage, which is typically the flow-in separation stage. It enables automated grind controls with a short response time, what we call macro control. You can relax the grind task, grind it to more coarse in a controlled way, all the time keeping account that you are not losing too much in recovery. And the hydrocyclones in a battery, they are not behaving similarly, but they are affecting to each other's operations, and you can see that based on this kind of measurement we can control every hydrocyclone so that they are managed individually, and a user can select that the best combination of hydrocyclones is in use. And if some cyclone goes to produce off-grade product, you can immediately correct that with your control actions. The secondary benefits are that you are, by this control, preventing roping events totally before they happen. You have the condition-based monitoring on the individual cyclones, and you are reducing the oversized particles that go to the flotation, so you don't need any more to clean the flotation tanks and lose production time for that. It also means lower water and energy consumption per produced ton. The controls provided by that are quite simple, and we do have our customer statements here that with these controls we are able to provide far more, increase the net metal production, and there is this kind of new information available about how the Cyclone battery is operating, that it can be beneficially used to stabilize the whole process after grinding. Like said, the hydrocyclones are affecting to each other's operations. We can see that when one cyclone is switched off, then the other one, neighboring one, can jump to produce off-grade products. So in this graph you will see the blue one is showing the old sampling-based control, and the red one is the particle size distribution based on PST control. So you are guiding all the cyclones that are in use in the battery to produce the same particle size which is optimal for your flotation separation process. And all the time you can ensure that the selection of best performing combinations of cyclones are in use. And especially you can turn it vice versa, so that you can avoid the use of worst combinations of hydrocyclones that can have a devastating effect to the particle size distribution going forward. Here we have a situation where one hydrocyclone has gone roping, and we can see that it's the blue line, and then the red line is the average. So if you have a sampling device following this, it would measure the average. And based on that average measurement, you would deduce that now there is harder ore coming in, and you would do totally wrong control decisions to limit the production, instead of finding out that it's roping now the event. So the macro control is focusing on the grinding optimization, the whole grinding circuit. It's just this new information, more reliable and real time, that is used to control that. The control logics are not very difficult, just simple solutions. And if you have several batteries, then you can run all the batteries to produce the same similar particle size distribution, which is optimal for your flotation. Then the concept of net metal production strategy is so that the optimum for maximized net metal production is not actually to maximize the throughput and recovery independently, but you can sacrifice some of the recovery to produce the maximum net metal amount in that production line. But how to do that in a controlled way, you will need this reliable information all the time, what is gained by side roll track PST in operation. Here we do have a list of concentrators where we have calculated that how much an increase of 10 microns in the average particle size or P80 value would increase their net metal production. And we can see that it's in a percentage scale for each one of those. Actually, when we have brought the PST to these systems, those increases have been even surpassed. So, because the benefits gained on the runnability of the total process by stabilization of this particle size distribution has provided extra benefits. One of them being that you don't have to clean the flotation tanks and you are not losing that production time. So, if you are having the ideal control set point and the particle size is below that, you are losing in throughput capacity. And if you are clearly above that, then you are losing too much in recovery. So this kind of controlled all the time, this process is in your user's control to keep it in the optimal particle size distribution point so that the net metal production is maximized. Some customer statements here tell that with PST we are pushing more tonnage and producing more net valuable metal. On the commissioning of first Cyclone track, the large copper concentrator found out that immediately after applying this calibration model, the particle size distribution in that cluster where it was installed is lower than in the rest ones. So sharper distribution. And a large platinum mine in South Africa, shortly after commissioning, noticed that they have a hole in a vortex finder. So one cyclone was all the time had been producing sand. And a metallurgy superintendent in a large concentrator told that they identified underperforming cyclones, identified that the gravel was being produced online, identified one plugged cyclone, identified also a sanding event in Launder. Here we have an example from Kennecott Utah Copper, the biggest copper mine in North America. They did 6 months trials. So running the process 6 months in the same particle size target with the old sampling based particle size information and then switching into PST control. And the result was that with PST control they gained 10% more net metal production. So the value of that was something like $60 million per year. Quite rapid payback time for this kind of investment. Also they found out that the specific energy consumption in grinding per produced ton was lowered by roughly 1 kilowatt per ton, which is of course from avoiding the underloading statuses of grinding mills. And previously they, before they shut the flotation cells for maintenance, for cleaning every 6 to 8 months. Now with PST and control they don't have to do that. Minera Los Pelambres had this kind of problem that with lowering ore content, their net metal production was decreasing. So they made a project for that, and the NMP strategy was part of that project. And they are saying that the PST use with this NMP strategy was a cornerstone for this strategy. The result was that there was 6% increase in production tonnage. They sacrificed 0.9% in recovery, so in net metal production they increased 5.1%. And the previous year goals for copper were surpassed. And then they move on with the production to other parts of the project. Another big copper mine found out in commissioning stage that 5 cyclones in a battery were producing off-grade products. With PST, this was quite easy thing to be corrected. And the payback of this investment was quite immediate. There we have the case from South Africa, how we can see that the green line there shows that one hydrocyclone is behaving abnormally, so they found out the hole there in the vortex find. Another case from a gold mine in South Americas. So they invested on this PST and utilized the NMP strategy, and as a final result, their net metal production was increased 8%. A copper mine in Bulgaria started to use this in 2018, and the following year they announced in the conference that they have gained 5% increase in production combined with 2% improvement in recovery based on PST. So PST has shown that the milk classification circuit is really the process area where the greatest potential for net metal production improvement can be made with significant economic benefits and in a short time. The primary benefits of this PST are that we do have a real-time direct particle size control, and we are controlling both the individual cyclones and controlling the total grinding circuit to produce the optimum particle size distribution for the flotation stage. And you can then, in a controlled way, trade between recovery and throughput. Secondary benefits are that you are preventing all the roping events, and you are having a reduction in specific energy consumption per produced ton. Roughly 1 kilowatt is the average per produced ton. Also, reduced water usage is one result of these findings, and it gives you a new insight into the process. So the total process variability is decreasing. So the rest of the process is running more reliably, more smoothly, and you can guide it to the targets. And you are not needing cleanings of flotation cells. You are not losing extra production time for that. And that means also improved safety and reduced man hours because you are not needing any visual inspections, manual samplings, cleanings of the flotation cells, so confined space entries are lacking there. So that is my topic, and you are welcome to visit our stand nearby, 257, to discuss more of Sidra solutions. Thank you for your
Har du stängt av mikrofonen? Testa mikrofonen. Prata igen.
Hello. Okay. So, hi, my name is Michael Larsen, and we talk about the Altaroy platform. Why connecting? Well, let's face it, the industry has an awareness and accountability problem. It was true even before era of staggered shifts, remote work, outsourcing to contractors, and social distancing. But that won't be useful to help keep the workers safe and worksite productive. Solutions that are connected from the ground up will interact with the total organization and its process, where actionable data helps drive safety forward, create awareness and productivity, correct fault behavior, and foster a culture of accountability, enable real-time responses, and the wide adoptions of standard operating procedure. Well, this is why over the past decade, the industry has been pushed towards connectivity. The solutions that are available in the market come with some major drawbacks. Some devices are connected, connectivity is not integrated, activating the solution sometimes requires difficult infrastructure. Other devices are connected. Devices are not rugged enough to withstand the challenge of use in an industrial environment. Battery life is limited and degrades over time. Therefore, organizations have been chasing after simplified compliance because going beyond that was technologically impossible. Now that devices with add-on connectivity are already in the market, massive amounts of data are being generated every day. So it's not so much about data isn't available, but in reactive safety culture, it's only ever used when incident happens. However, an industry platform that is connected from the ground up will completely change that. It will automate compliance so that you can focus on what really matters. Keeping workers safe in real time. Creating smarter workflows to keep work sites and coordinate and productivity. Creating better process to ensure assets reliability and worker accountability. This is what the Altaroy gas section variable is all about. So, how does it work? With the Altaroy 4 and its integrated cellular connectivity, industry workers are always connected, straight up off the box and ready to go with a tap. You won't require any additional infrastructure or activation carrier bills. We move past away from the cell phone acting as a gateway. The Altaroy 4 is connected with the grid software platform from the ground up without compromising on durability, and this is our most rugged Altair yet. The Altaroy 4 has been tested under the hardest condition and boasts a work-proof design with unmatched durability. It has a military-grade durability rating and the ability to survive 25 feet drop test, as well as exposure to extreme temperatures. This is also reflected in MSA patented rugged sensor technology that leads the industry in response time and lifetime. This is why the IO4 is the industry's first integrated, compact, connected hardware solution that makes no compromise on ruggedness for technology. The detector cylinder profile and long battery life show that with the Altaroy 4 connectivity, and despite cellular and GPS technology that is fully integrated into its rugged design, the Altaroy 4 is still light, compact, and easy to wear. The Altaroy 4 has been built with a sensor technology you've come to trust. The Altaroy 4 comes with MSA patent rugged sensor technology XL. That delivers an incredible fast response time, half of that of competitive devices, and 5 to 7 years sensor life which is twice as long compared to competitors' solutions. Product features overview. And this is just on the end. The Alta IO4 comes with another great innovation that will allow you to digitally assign devices with a tap and return them with a click with MSA ID. The RFID tagging system allows workers to check in and have device assigned to them without infrastructure, manual process, or clipboard sign-ins. Other features like the device lockout that blocks the device from being used until it's made compliant. Makes the solution easy to integrate with your standard operating procedure and most important, your systematic environment work. MSC ID promotes accountability and compliance of use, as all real-time and historic data is tied to the worker. Just like the initial assignation, you can manage device returns digitally and without any interactions needed from your user. Simply place your device in the charger. It will securely mark your device as returned to the company. Upscaling for shutdowns or engineering work will be made easier for you with integrated RFID tags. For the first time, you can capture a 24 work cycle without human interaction. Market first. The IO4 collects and transmits all device data to your safety grid software account. With constant cloud connectivity and integrated GPS, your safety program will gain complete visibility. You will know when and where something happens and who it happens to. Your safety program shouldn't be about chasing after compliance. It should be about the evaluation of your process. The IO4 is a device that enforce compliance for you with available and actionable data. You can stop firefighting and benefit from automated fleet management. Your systematic environment work will be easy and automatic. The Alta 4 is also a gas safety monitor that facilitates over-the-air updates. New functionality or settings can be pushed periodically to your device. This will ensure that your entire fleet has a standardized configurations. Beyond that, the safety IO is also being continuous updates to support new features. This way you can continue to improve your safety program and benefit from a highly configured fleet that is flexible to changing standard operating procedure, all without additional investment. Shows the instrument. Edit configurations. Shows configuration. Change and upgrade your fleet. Simply. Plug in system in and get going. You will require no networking with the smarts of the Alta IO4. You can just plug in the device in the right test start automatic. We designed the Alta IO dock test stand for your rugged use, a fully integrated gas management system. The IO dock is made for mass bump testing and calibration. It can accommodate up to 10 test stand and three cylinder holders. This way you can bump test and calibrate waste device fleets with no changes. Monitor stands from the cloud. You will not require any networking thanks to IO4 integrated connectivity. This way you will know ahead of time when and where calibration gas is needed across your entire fleet. Automated replenishment. And all the information is gathering to the grid. With Alter 4, there are active safety features, including every device. Every piece of data streamed instantly to the cloud. Remote emergency alert monitoring will be prevent false alarm. You can configure and monitor your entire fleet from anywhere in the world with a click of a button. The Alter 4 collects and transmits all device data to your safety IO Grid account, where it's organized into intuitive, actionable insights on the fleet manager dashboard. Your safety program shouldn't be about chasing after compliance. It should be about the evolution of your process. The IO 4 Grid and Grid Fleet Management enforce compliance for you. You can stop firefighting and benefit from automated fleet management. Furthermore, proactive sensor and calibration gas replacement will prevent unwanted downtime and increase the flexibility of your fleet. With IO4 and Grid Fleet Management, end user benefit from bump test and calibration documentation, as well as incident report per specific event that are automatically generated in an industry standard format. User can review not just whether their device has been set up, configured, and calibrated correctly, how did each sensor perform, but also obtain behavior and ask the most important question: are there process-related problems that need to be addressed? Find the device. Orange and yellow means actions. Print the incident report, download it, all the information you need. With constant cloud connectivity and integrated GPS, your safety program will gain complete visibility. You will know when and where something happens and who it happens to. MSC ID puts a person behind every device. With the IO4 and Safety IO Grid, you can documentation and process incidents as part of your follow-up operation procedure to make sure that even data is tied together with incident investigation for the holistic and comprehensive historical picture. Over there, update is automatic. It means that when you have new updates that you need to have, it's no problem. We will update it to you. You just print, and it's very easy to do. We update it, you gather it, and you download it, and hold the fleet, get all the update that you need to have. It's automatic. This is our device. Functionality. MSA Plus, safety simplified. Instead of owning assets and high upfront costs, MSA offers a HAS monthly subscription with low fixed payments. You can get your gas detection program approved and running with a low and predictable operating expense that scales with your fleet. There are two big benefits from this new way of doing things. You always keep pace with technology. Technology is being introduced at a rate safety programs have never seen. It always operates to the latest device generation when it's available and no cost. And two, your tech device is always under warranty. And most important, this will automatically help your organization systematic environment work and give you actionable data that helps drive safety forward, create awareness and productivity, correct fault behavior, and foster a culture of accountability, enable real-time responses, and the wide adoption of standard operating procedure. Connected Worker is a part of our platform. Connected Worksite, Connected Workflow, Connected Workflow. Thank you. What else I want to say, if you want to test the products, if you want to understand how it functions in your area, it's not a problem. We will come to you, we will show you your product, you can test the products, how it functions in your area, and that will not cost you anything, sir. Welcome and thanks a lot. My name is Michael Larsen, and please visit us in Copperhead, stand 209. Thanks a lot.
We are mouse. You should.
With Elon's Tesla revolutionizing the entire car industry, his Boring company making tunneling more possible than ever, and SpaceX single-handedly creating the world of privately owned space exploration, there seems to be no limit to his achievements. However, recently, there have been rumors that the legendary tech god has his eyes set on another industry that he seeks to change. And if he does, it will affect every single one of our lives. That's right, rumors have not only been circulating around, but have started coming from major sources that Tesla is out to create a phone unlike any other, one by the name of the iPhone, that will work on Mars, have 5G level internet in the Sahara, and will be able to change its color. But does Tesla really have a shot at making this phone? And how does it compare to the world's current leader in technology, the Apple iPhone, which you might be using? The answers to those and more are in this video, so buckle up if you want to learn more. And with that said, let's take a look at both of the competitors with their history and background. iPhone. Ever since its release all the way back in 2007 at the hands of Steve Jobs, who some might say was an Elon Musk of his era in his own right, the iPhone has gone on to become the most revolutionary piece of technology to have ever been introduced.
Hello. Hi and welcome to this presentation about process optimization for concentrator plants. And we, SPM Instrument, have been using something called HD technology for a very long time. It's a unique patented measuring technology with a very, very high accuracy, a high signal to noise ratio, and it's unique in the condition monitoring world. Now we have been applying these methods in a mining process, especially in the enrichment process. And if you look at this typical process from mining, so there are so many different types of processes in mining: hard rock mining, soft rock, iron ore, and that type of processes. So in this example of a typical mining process, you see down here to the right, you have the crushing section. Can be your yaw crushers or giratory crushers, cone crushers, and that type of application. You have a hoist. So if you have an underground mine, you have a hoist. If you have an open pit mine, you don't have a hoist. Conveyor belts, very important. You have the mills. In this case, it's a primary mill and a secondary mill. We have pumps here. and we have shaker screens, vibrating screens, important in the process. We have more pumps, and we have the flotation area here. So if you look at this very modern process from a modern mine, it's typically a single flow. In older types of mine processes, there were several smaller parallel flows. So if one broke down, they could still run the other ones with a good throughput. But in a modern mine, there's typically one single line, a single flow line of ore or money. So the red line here is that's the way the ore flows. And also the money and the revenue and the profit goes through this single flow. And if you have a breakdown, for example, in a crusher underground, that's a huge cost and a high risk. Or if a conveyor belt fails, you can repair it, but you lose production time. And what is more important here is that in a well-balanced enrichment process, the mills here should be the bottleneck in the production, because the high capital cost involved to set up this and buy this and start and commission it is extremely high here and here. But also the operating cost, the OPEX, to drive this. Imagine to turn these mills around with a very, very high energy cost. So high capital cost and high operating cost is related to these applications here. And again, a well-balanced enrichment process, the bottleneck should be exactly here. And if you follow this flow here, from the mills, it goes to the shaker screens, and particles that are too big to be processed in the cyclone or in the flotation part goes back here and is regrinded again. So this return flow here is not optimal. You want to have it go in this direction here. The same with the cyclones. Particles that are too big, they are passed back and regrinded again. So they lose some of the production if they need to regrind it again. What is scary here, or what is strange, is that you can measure the flow, you can measure the temperature, you can measure the weight, you can measure so many things in the process, but the most important part of the process, which is here, and the most expensive part, you cannot measure. You are blind, you don't know what is happening inside, because it's almost impossible to measure. For example, if you put in a camera here, it will be destroyed in 1 second. So it's very, very hard to measure what is happening inside these mills. The inner state of the mill, that's a question mark, until now then. And we have invented a method to, with a very, very high precision, measure the toe position inside the mills. And it's a unique method, and so it's unique for us. But also the screens, we have applied HD technology on the screens and the pumps. So these three applications, I'm going to show you some results with a view of process optimization primarily. So let's start with the shaker screens. So we have developed a dashboard. So it's based on vibration sensors. So you have the screen is doing this type of movement here, and it's spring-loaded in each corner, and we have a vibration sensor in each corner, and we can describe the orbital motion of the screen. And if it's deviating too much, the ore flow on the screen is not going to be optimal. And what you see here on the screen are 4 corners on a vibrating screen. So the green one, that's the right discharge. The blue one is right discharge, right feed, right discharge, and the other corner. So 4 corners described with vibration orbits. And the unit here is millimeters. And what you see here is 4 corners. And ideally, they should be very, very similar in shape and the angle and the amplitude. So they should be very, very identical almost. This one is not. This one is not identical because this corner here, the right feed, has a different throw angle. So this means that the ore is not uniformly distributed on the screen and is shaking in this type of direction. And they lose production because of this. So this is a solution based on vibration technology. And of course we have a summary. So the motions here are described with some numbers here. So we have the max throw amplitude, that's the peak here, and they are a little different. The throw angle, which is the angle towards the horizontal line like this. And if you look at the throw angle here, the green one, which is this one, is deviating a lot from the rest of the orbits, meaning that this shaky screen is actually doing a tilting movement like this, and is not, the ore again is stuck in one corner, and they don't use the whole surface of the screen. But also the orbit ratio, which is the ratio between the most narrow part here on the orbit and the maximum deviations. That's the ratio between these two. And in mining, it's preferred to have a linear motion, not this orbital motion. It's a linear motion they desire. So the purple one here, this one, is doing an almost linear motion, which is close to the ideal movement. The other ones are not. So this is an example of a shaky screen not performing in the most optimal way because these deviations. And this is a web-based dashboard that we have developed based on vibration technology. And of course we have some history here. This is going back 1 month in time, and we can describe if there is a change over time of the angles and the amplitudes. The next application are slurry pumps. You know, slurry pumps, that's a centrifugal pump actually. And if you look at this animation here, so you have the inlet here. You have in this case 6 impellers. And in this animation, every time an impeller tip is passing the cut water here, there is a pressure pulsation generated, a pretty strong one. And this pressure pulsation is manifesting itself as a vibration. So we have a vibration sensor here and in other places, and we can describe the behavior of this pump. And in the next slide, we have actually real readings from a mining operation. So this is a slurry pump with 4 impellers. And to the right here, this is the vibration pattern. This is the pattern, vibration pattern from this pump. So if I go back again, in this case, it has 6 impellers, but in the reading I show you here is 4. So if you look at this pattern here, so every time an impeller tip is passing the cut water, there is a pressure pulsation. So this is one vibration reading here, a tip, and then the second one, the third one, and the fourth one. So this one is describing 4 impellers passing the cut water. And if you have very high vibration, that's not a good sign for this pump. It's not optimal. What you see to the left here is a trend graph of the same pump. And when I'm going to play this movie soon, the vibration levels are pretty low, normal behavior, but suddenly there is a huge step here, and then the readings goes back to normal. And the scale here is 24 hours. So roughly after, say, 30 hours, it goes back to normal operation. So if you look at this movie here, this is 1 minute describing 30 hours of normal operation. This is an example of our HD technology. So these are the impellers. Nobody else can do this type of measurements, so it's so clear. The impellers are there. And they are very nice and clean, and they are like very uniform. But if you look down here, something happened. You see there is a deviation here. These ones are normal, this one is deviating from the rest. So this is most probably, or not 100% sure what happened, but most probably a part of the impeller surface were broken away, and it was semi-attached to the impeller. And it was slowly breaking away, and then it created a hole. So it went back to normal, but not exactly to the same initial stage. So this is an example of impeller malfunction. And typically in mining, it's very, very typical in mining that, or in many process industries, that you buy this huge pump. The pump is too big for your needs. So they buy this huge pump and they think that, okay, this pump will handle a lot of pain, so I can run it for many, many years with no problems. And that's a very, very common reasoning in mining and other process industries. So they buy this huge pump, they put it in their process. So what will happen? Well, they have to go down on the flow, so they cannot use the maximum flow here. They need to reduce the flow to a minimum. So the pump is huge, but the flow is minimum. And that creates a lot of stress on the pump. So they have premature failures on the pump because they are running so far away from the best efficiency point. Very common in process industries. Now, the main topic for this presentation is the toe position monitoring. Again, in a well-balanced enrichment process, the mills should be the bottleneck because of the high capital cost and the high operating cost. So, around 2% of the world's energy goes to crushing. Blasting, crushing, and grinding minerals. That's a lot, 2%. That's enormous. Some say 4%, but still high numbers. And 50% of the mineral processing plant operating cost, and even higher for the capital cost, goes to comminution. That's extremely high numbers. And again, for the fourth time, in a well-balanced enrichment process, the bottleneck should be the mills. And that's very important. I go back to the first process chart here, where you saw this. So imagine now, you have the flow of money, the flow of ore here going in this way. And if this is the bottleneck, because of the high cost, if you can increase the throughput here by, say, 0.5%, or 1%, or 10%, by optimizing the toe position or the filling rate inside these mills, it contributes to the profit directly. So this is very, very important. In order, if you want to increase your profit, pay attention, focus on these. And tumbling mills, there are basically 4 types of tumbling mills. We have the rod mill, which is a little old-fashioned, you can say, but still exist. They are very important. We have the ball mills, the sag mills, and the AG mills. And the invention that we have invented, the toe position monitoring, is directly applicable for ball mills, sag mills, and AG mills. Not directly on rod mills. We have not verified that. Maybe it's possible, but that's a little outside our scope. We are focusing on these 3 mills. And ball mills, they are perhaps the most common type of mill in the world. These are common, and these are pretty common, the AG mills. We have plenty of experience from ball mills. We have a long experience from AG mills measuring toe position, but not so much from sag mills yet. Needs to be verified, but we are pretty sure, or we are sure that it will work directly on these as well. And typically for ball mills, they are used for fine grinding, and these are more for coarse grinding. So, when you talk to mining people, they are mentioning the charge, which is the ore inside the mill. That's a charge. We have the toe down here. We have the shoulder lifting up the ore in the air. And we have the lifters, which are the black structures here. And if I start the animation here, you see that this part of the charge here, the toe, is hit by the lifters, and the material here is going this direction and is thrown up here in a cataractic movement, and it's down, falling down and crushing the ore here. So this part here, that's crushing. It's actually impacting like this, and the higher the trajectory is, the more energy you have in the crushing moment. So crushing is happening here, but there is also abrasion. That's the particles grinding relative to each other, and it's also a part of the comminution process. So crushing and abrasion, they are very important. If you look at the ore here in the toe area here, the ore is practically standing still. So nothing is happening, it's standing still. The ore particles are standing still, and suddenly it meets the lifters. And if you follow this part here, from standing still to the peripheral speed of the mill, that's a huge acceleration. So standing still, that's zero velocity here, and then it suddenly goes to say 4 meters per second. That's a huge acceleration, and there's a lot of ore here. And when this is happening, you push a lot of ore, several tons, in a very short time, so the whole mill will be kicked. And you feel it in your legs when you're standing still close to a mill. You feel that they're shaking like this, and that's what we measure. That's exactly what we measure on the main bearings. We are measuring the impact between the toe and the lifters. That's what we measure. And then we have a reference on the shell, and we are comparing the time difference between the reference and the impact. Show later. And also, if you notice here, if you have a very high filling grade, and filling grade, that's the ratio between how much ore you have inside compared with the total volume. And a typical optimal filling grade is between 30, 35, 40%. If that filling grade goes up, so you have more ore here, the distance that these particles falls down, the energy is lower because the speed is lower when it hits the toe. So you lose efficiency in the comminution when the filling grade goes up. Now, we received particle size information from a ball mill somewhere in the world. So these are real data from a ball mill. And before I proceed with this part, there are two user benefits of measuring the toe position. Two very important benefits. One is to avoid fault conditions, like overload and freewheeling and that type of stuff. You can easily detect that by the toe position measurement here. But the other benefit is the relation between toe position and the particle size, which is very, very important for the process itself. And these are real data. I'll start with a particle size relation here. So these are real data from a real mill somewhere in the world. It's a ball mill. I received 100,000 readings from this mill, and I created this histogram. So down here, in the X direction, you have the particle size. So I change side here. So down here, you have 100 micrometers up to 400 micrometers. And the bulk of the readings are here. And these are the number of results. So most of the readings, or most of the particles, are around 260 micrometers. This is typical for their process. But the recovery rate for this process is maximum here, according to this mill. They want to be here, but they are there. So the recovery rate is not optimal. They should be here. And by using the correlation between the toe position and the particle size, you are able to move the bulk of the readings to the wanted area, the highest recovery rate area. And also to squeeze the distribution, to have it more tight. So using toe position measurement, and I'll show you the relation soon, it is possible to optimize the recovery rate. But of course, if you optimize the recovery rate, the throughput can go down, so there is a balance there. So, if I show the readings that I showed you before, 100,000 particle size measurements, and if I use this graph here, where I have the particle size 200 up to 320 in this direction, and here I have the toe position, high toe position and low toe position. And then I plot all the readings that I received from this ball mill. No filtration, these are raw values. I have this cluster, 100,000 readings. And if I use the least square method to have a line combining these points in the best possible way, the blue one is the relation. So what you see here, hopefully clearly, is that if you have a low toe position, the particles get smaller. And if you have a high toe position, the particles gets bigger. And that's pretty logical, because if you have a high toe position, the speed or the energy at impact will be lower, because the time, the distance that they fall are shorter. And a low toe position means that the energy at the impact is higher. So there is clear a relation between the toe position and the particle size. which is extremely important. So this is the particle size toe position relation. And this is the target area, so to say. And by using the toe position, you can go down here. Fault modes. In normal comminution, you have around 30-35% filling grade in the mill, and these are thrown here, and you have a pretty nice situation where everything is working fine. And you have a steady inlet feed, so say 500 tons an hour, everything is fine, and you just feed in and you grind. And suddenly there is a change in the ore composition, the hardness of the ore. It takes longer time to grind. So the longer time it takes to grind, and you have a constant inlet feed, that means that the material is building up here. And if it's building up, the trajectory gets shorter and shorter and shorter, so the efficiency goes down very, very quickly. So typically, overload is when you have harder ore, you have a constant feed rate, and you have this situation, which is very, very common, both for bore mills, AG mills, and SAG mills. If this happens, you don't see it. It takes some time before you notice that, okay, something is strange here. It's a little too late, normally. You have to stop the inlet feed totally, and you have to grind out. You have to empty this one. And when you have a lot of ore, this process is inefficient. So it takes a long time to empty the mill or go back to normal. So you lose production. The blood flow of money, it will be stopped. So that's not good. There is something called freewheeling. That's when the material is clogged between the lifters. It's like little, it's clogged. So this one is only rotating and no impacting occurs at all. So it's like spinning around, and that's not efficient. So it will lead to overload, and we detect that. The third one is slurry pooling. That's when you have liquid, water building up here, and when the stones or ore is hitting the water surface, the comminution is very inefficient. We don't measure that directly. It's not possible with our solution to measure this because the impact between the water and the lifter is too weak, so we don't see that. But this leads very, very quickly to overload, and we see that. So if you summarize the user benefits, one is the particle size distribution and the recovery rate. The other one is to avoid fault conditions. So both are important and possible with our solution to detect. And the fourth one, lifter damage. As I mentioned before, we are measuring the impact between the toe and the lifters. And that is occurring not only one time per revolution, it's occurring 1, 2, 3, 4, the number of lifters per revolution. So if you have one lifter or several lifters that are damaged or loose, we will see that. In our competitor solutions, they have something on the shell, and they have a strain gauge to one lifter, and if they have a problem here on this lifter, they will not see it. But we are using each and every lifter as a sensor in our solution. So we can definitely see lifter damage. And that's important and unique for us. Now, the way we show data is not like the standard way of showing data, but just for pedagogical reasons, I will show you how we show it. So this is a cross-section of a mill, and I will run a simulation shortly. But just to explain what this is, you have the lifters, you have the toe position, the red dot here. I added a scale because the movement of this toe position is very, very small, so it's very hard to see, so I added this scale to have as a reference. And I have a simulation here. So this is the actual toe position. You see the red dot here. This is a toe, and this one is rotating counterwise like this, clockwise. And this is the toe position. The way we show it in our dashboard is in this swirl type of display. And there are several reasons to use this. We can choose, actually, in the dashboard, we can choose this type of view or this type of view. But the swirl view is it contains a lot of information. So when I start the simulation now, you will see that this starts to increase and go down, and I play the sequence here. And at the same time, the red dot here in the toe position display will also move. So you see the toe position down there is right now going up. And the movement is so small, so in our readings, when we measure on a huge mill, we have a less than a centimeter resolution of the toe position. Yeah, less than a centimeter in this violent environment with the rocks tumbling around, and we have water and this huge energy at the impact, and we have less than a centimeter resolution of the toe position on both ends, both the inlet side and the outlet side. And there is always a small difference between the inlet side and the outlet side toe positions in the normal state. I come back to that. So when you see this movement here, each small step here is less than a centimeter on the shell. And right now the toe position is going down. If you look at the real toe position, it's going down slowly. It's very hard to see, but here it's actually going down here. And when it goes the whole way down to the middle of the swirl, that means that the mill is empty. And there is a gray dot, maybe hard to see here, but there's a gray dot. That's the reference point for an empty mill. So right now it's going down. And you can imagine the ore here is not so much inside. The charge is the amount of charge is low. Now they started to increase the toe again, goes up. So when you have anti-clockwise movement like this, going out in the swirl, that means that the amount of ore and the toe position is going up. And if it goes down here, that means that the toe position is going down. So that's the toe position. But also, if the density of the ore between the lifters are very, very high, so not so much water, more hard ore, the readings are out here in the arm, and if there's a lot of water in the charge, it's on the inside. So we have the inner state of the mill. The inner state contains the toe position, but also the density of the ore and the water content in the ore. Now you see the toe position is going down, and you see the real toe position is there. So this means empty mill. So the reference point for empty mill, a grind out, is when it comes here. And it's soon going to that position. So in our dashboard, in our way of showing data, is either this traditional view, it can be hard to see the movement, it is there, or you select this swirl type of view, which contains a little more information, especially about the density and the inner state of the mill. So now it's actually increasing again. These blue dots here, they are real data. They are real data from an iron ore mill. And it represents 1 month of toe positions. It's 60,000 readings in this blue whirlpool here, or swirl. Real data, and I just made this animation to use how it's moving. Now, if I go fast forward here, and I go to this one. Now, the toe position is going up. The ore is harder to grind, takes longer time to pass the mill. The operators has no idea if they don't use our system, of course, but normally they have no clue. The toe position is going up, they don't see anything. And when it reaches this area here, you see the charge is somewhere here. It's approaching overload, and the trajectory of the ore particles hitting this part here is becoming shorter and shorter, and the energy at the impact is going down. So this is like an exponential development here. It's going faster and faster and faster, and then you have overload. And we have a reference mine in Norway where they have been using this for close to 3 years, and they used to have issues with overload. That's, I would say, completely disappeared. And you can avoid unexpected stops in the process. So this is a screenshot from the real mill, and you have the swirl here, and you have some dots here, and you see this is actually an empty mill. So this one is grinding out. So they stopped the inlet feed for some time, and then the toe position went from a normal position all the way down to empty mill here. And we have roughly 30 seconds between the readings. So it's going pretty quickly, actually. So 30 seconds between the readings, and it's going to empty mill pretty quick. And we have some information here about the process, tons per hour, the power to the motors and all that stuff. It's user selectable. But this is like the dashboard, a web-based dashboard. And this mill, our reference mill, they are using this dashboard type of style or view in their control room. And they are totally depending on this. This is a ball mill. It's not a nice swirl. This is a nice swirl. This one is not so nice. But the reason for this little cut-off swirl is that a ball mill is normally much more stable in terms of toe position. So the toe position is not varying so much. It's a small movement. So, and this is the highest toe position, and this is the lowest. And if you look at the shell of the mill, it's only 12 centimeter. And if you look at the dots here, they are like less than a centimeter in resolution. That's extremely accurate. This is a typical autonomous mill. You have the inlet here, you have the outlet here, and as I mentioned before, we have one vibration sensor on the inlet and one on the output or outlet, and we can simultaneously measure the inlet toe and the outlet toe positions. And if the outlet toe goes up, but the inlet stays low, that's a typical fault conditions where the output is clogged. And we have seen that a couple of times. They lose production. To summarize the benefits, first of all, the correlation between toe position and the particle size, that's the recovery rate related, is extremely important. Fault modes, of course, especially the overload, that happens quite often. We are comparing the inlet and outlet simultaneously, so a clogged output or outlet can be detected with this, which is unique for us. Nobody else has this capability. We can see all the lifters. The installation is extremely simple. It's 2 vibration sensors on each bearings, the main bearings, and 1 tacho. Nothing on the shell. And that's extremely important as well. So if you mount some strain gauge electronics with wireless sensors and antennas and batteries on the shell, and then you have a stop and you want to change the lifters, and people are crawling all over the mill with huge tools, that's not so optimal for the sensitive electronic parts. We don't have that solution. We have 2 robust vibration sensors on the main bearings and 1 tacho, nothing on the shell. This is the feedback that we have received from many mining sites. We don't want to have anything on the shell. It's too sensitive. And finally, the system configuration. You have the mill. We have the sensors, 1 on the main bearing here, and 1 on the main bearing there, and 1 tuck, which is an inductive probe. And you use a bolt or some kind of bracket or metal part of the shell itself, and you have 1 pulse per revolution type of signal. That's it. And of course we have a measuring unit, but that's somewhere else. It's not on the shell anyway. And we connect the vibration sensors and the tuck to the unit. We have a REST API interface, meaning that the control room and the experts in the mine can extract this information and use it for machine learning and AI, if they want to. We have this dashboard that I showed you before with the swirl. This one. And of course, the toe position and the inner state of the mill can be used for the mill control system here for machine learning purposes. So we have the dashboard and the raw values to the control system. And that was all. Vibration-based toe position monitoring. And it's extremely accurate with a high resolution. Okay, thank you.
Okay, hello everyone. My name is Marko Holma. I am the CEO of a Finnish company, Muon Solutions. And today I will talk you and tell you about cosmic ray imaging with the title Advances in Cosmic Ray Imaging Technology, Applications of Muography in the Mineral Exploration. So first we have to define what muons actually are. Muons are elementary particles that cannot be subdivided into any smaller particles. These are generated by the Milky Way, basically, when it sends primary cosmic radiation to the Earth. The upper atmosphere of the Earth is reacting with this particle all the time. The process happens in about 15-kilometer heights. Okay, muons are also called as heavy electrons. They are about 200 times heavier than normal electron. These go through almost anything in scales of hundreds of meters to few kilometers. These are unstable particles, and when they go through material, they react with the material by losing energy, which means losing speed. When this happens, they cease to exist. So the best analogy how this method works is medical X-ray imaging. But there are two major differences. First, we don't have to generate the radiation like in X-ray imaging. Instead, we are passively watching the universe. Second, X-ray imaging works only in up to few meters of scale. This works in tens of meter scales to hundreds of meter scales, and even in kilometer scales. One more thing about muons, they go in straight paths. So by detecting muons and the directions where they are coming, we build up statistics, and statistics are translated into 2D or 3D density models of the object. And the object can be rocks, or it can be industrial thing like refinery or whatever. And another thing, muons are available day and night everywhere. They are not coming from the sun. Then muons and how they go through material depends on the initial energy, on the angle they are coming from, plus the average density of the material. Examples what are in applications in geoscience include imaging of volcanoes and monitoring of volcanic activity, mineral explorations, and many other things related to geology, including structural geology, tunnel detection, void detection. They can be natural caves or man-made tunnels. And we can also use this for aquifer monitoring, which means groundwater monitoring or discovering groundwaters. Then I'm repeating myself. Muons are coming from the space, from the Milky Way, and you can see the process in the lower image. So the Milky Way is generating radiation, and each primary cosmic ray produced hundreds of thousands of secondary particles, from which muons are what we are interested in. These goes through with high energies through material. The particles or muon particles generated by the radiation of the sun, that generates very nice polar lights, but they don't produce very interesting muons because they are too low energy and cannot go through a lot of stuff. Then our company has two types of detectors: muon porehole detectors, cylindrical shape, about 60 millimeter in diameter and 2 meter long. Then we also have telescopes. In this case, the model is about 60 kilograms in weight, and it has a diameter of about 80 centimeter by 80 centimeter by 50 centimeter. These can be modified according to the application in different sizes. Even container-sized big detectors can be built. Then these two different detector types have a different field of view. The telescope model can be installed like that in horizontal position, or it can be tilted to face some target. The target can be a volcano, it can be a mountain, cliff, or it can be, if you install this in underground tunnel, like in this case, it can be hundreds of meters of rocks. And what we can do is to make a 2D or 3D model where your heavy targets, high density objects are. borehole probe has a different field of view. It's a conal data cone like that. And the general rule of thumb is that if your borehole detector is positioned, let's say, in a 100-meter depth, the cone has a diameter on the ground level that is twice the depth, so 200 meter already. So if we put this in 500-meter level, we will see huge volume of rocks where the densities are. Like a diameter would be of the data cone 1 kilometer already, or even longer or higher. Then this kind of summarize what I have told you so far. If you have a high density object or body, like a human body in X-ray imaging, the high density body would stop more muons, and the other ones would go pass through the detector like that. And this is how the data of the borehole detector looks like. There is one visualization and there is another algorithm used. And that's on the right hand side it's more how the data looks if it's projected to the ground level. So in this case you can see low density, this bluish one color going in that and in two different sectors, which mean geological interpretation is that there might be a fault crossing this way. And if you are interested about this kind of tectonic lineaments, this can you can use this tool for guiding drilling, for instance, or you can use this for water exploration. The drill hole system is self-sustaining. We use solar panels and windmills to produce the energy we need, and actually we need very little. So the current battery system, even if you don't recharge your batteries, lasts about 1 month before you need recharging. But if you use these renewable energy sources, you can run with this months. This is how looks the telescope data. This is two-dimensional image called muon radiography, and lower right-hand side you see a three-dimensional visualization of a volcano. That's muon tomography. And these two other images are showing density data in so-called polar coordinate system. More about this later. Okay, this is a case study commercially made with clients' underground mine. The mine is chemi-layered intrusion, located in Finland. Measurements were completed recently. This is how the data looks like. In this case, the depth was around 300 meters, and we had, in this case, 2 places where we installed the telescope. Here we refer to them as Site 1 and Site 2. So these were separated about 40 meters. Not perhaps ideal for making very different images, but in this case it's an operational level, so we were not allowed to go too far enough. But you can see some density changes here. So in polar coordinate system, the data looks like this contact looks like curving, but actually it's a planar. So you need to a little bit learn how to read this. But the important thing is that we can now give numeric values for the rock densities, and that could help the mine engineers and mine geologists to redesign where to put their tunnels or how to direct your drilling. Then what we have to do to the data before it's ready for interpretation is that we need from the client a good quality digital terrain model. So we need to know how high your ground is. On the right hand side you have an open pit. Naturally, if it's an open pit, there is no rocks. So muons are not losing energy in that hole. So it's kind of window, we get a lot of muons through that. Okay, it's good also because now we can go a little bit deeper if you have an open pit nearby. That will pass more muons. This can be corrected by knowing or having the digital terrain model or LIDAR data. Then a little bit more about the applications in geosciences. In this case, regarding where we are now. I'm mainly talking about mineral exploration. If you are interested about any other applications, which we have numerous, please come to our booth 288. We can discuss more about this. But in mineral exploration, this can be used for target discovery. So if your target is a heavy, dense ore body, we can give you coordinates where to drill. Then we can also optimize drilling patterns. So we can reduce your unnecessary drill holes. We can also characterize your geology. You can verify your geological models or block models. This could be also used for detection of faults, anything that has a lower density comparing to the country rocks. One more example. Many ore deposits are related to hydrothermal fluids, and the fluids typically have changed the density of the rocks because they have changed the mineralogy. And in many cases, with many ore deposits, the hydrothermal alteration halos or envelopes, they are volumetrically much bigger targets than the actual juicy stuff, the ore deposit itself. So many cases, mineral exploration geologists and geophysicists target these alteration halos first. When they find these, they start to look into other techniques, how to pinpoint where the ore might be. Sometimes you only have these alteration halos without any ore body. Then here you can see where we think muography can be used in mining industry. We can start in a very early stage when you don't even have boreholes, not saying drill tunnels. That would, however, that would need that you have a topography, some sort of mountains. We could install a telescope in this kind of terrain and then see through the thing. And all through the mine operation, we can also monitor after post-mining stage how your tailing dams are working, if water is infiltrating there. In the left-hand side, you can see a cover of a recent book published in March this year, the first book about muography. We had one chapter there called Future Prospects of Muography for Geological Research and Geotechnical and Mining Engineering. Then the muography can be used for structural geology. If you have high terrain like this, you are very lucky if you have this kind of landscape, but you could also use the landscape by installing telescope in nice places and see through those rocks. A few more things. Every percent of density difference ends up in 3% density difference in the measured muon statistics. And this technique is most feasible in mineral exploration and mining engineering in the uppermost 500 meters, but if your need is much deeper, it might be doable. We have to know your other parameters. We can increase the number of detectors or make bigger detectors to solve this depth problem. And yes, also if the target is really big, it is an easier target, but smaller targets are not a problem either. Just have to change a few things. The already classic application is imaging of volcanoes. This has been done already over 10 years. There's a lot of peer-reviewed papers on this, if somebody is interested. Mainly these studies have been done in Japan, Italy, and Caribbean mainly. We have published a lot. You can find our papers from my personal ResearchGate profile, including this one, where we propose that muography should be taken into the regular monitoring systems of active volcanoes. In the very next day of the publication, New York Times published in their science pages a little about news about this. And then into my conclusions. Muography can image geological structures and features, whatever they are, but also industrial structures. Monitor whatever you have, where the density is and parameter that is changing. And this is a new tool for mineral exploration, and we are pretty sure it will make a big difference very quickly. Thank you for your attention.
Hello. I welcome everyone to our company's presentation. My name is Heta Järvenpää and our company is SKT Suomen Kaapelitarvike Oy. The company acts as a manufacturer, importer and supplier of mining industry machines and devices. For example, cable laying machines, cable and overhead line tools, and safety equipment. In addition, we develop specialized machines and equipment in the domestic and export markets. Suomen Kaapelitarvike SKT has more than 30 years of experience in the industry and more than 10 years of experience as a developer of mining equipment. Our customers know us as a manufacturer and supplier with a sense of responsibility, whose promises and contracts will be kept. We oblige this from our partners as well. We are looking for effective solutions cost effectively and quickly. We want to be a trustworthy and a long-lasting partner for our customers. The mining industry has become an important part of SKT's service and product range. Deliveries have been extensively extended to the Finnish mining industry in different mines. In addition, products and expertise have been delivered to, for example, Zambia and Panama. Suomen Kaapelitarvike SKT offers services to mines also in connection with the inspection, maintenance and various guidance and safety issues. Here also with fixtures. There you can see a reeler machine, cable reeler machine frame, double cable reeler, and special cable reels. There's also cable reeler machine in action. We innovate products for cable handling in mines. Here is also cable reeler machine, remote control unit, cable trailer. There's mining cable connection box, storage reeling device and special reel for mining cable ready for delivery. Cable assembly devices and trailers. Cable bridge, cable tower to lift cable to 15 meters high to enable safe crossing. You can find more innovative products in our web page. Thank you very much.
Hi, James. Be silent, please. My name is Carl Eriksson, and I'm from Svenska Elektrod. We house down in booth 202, and I'm here today to talk to you about XRF, but in usage with collaborative robotics. So I'm also actually going to talk a little bit about collaborative robotics, because I feel that that's a field missing here. If we're going into any other industrial exhibition, in any other context, we'll find loads of industrial robots today. But I don't see any other collaborative robotic in this whole fair, apart from the one that's in our booth. Just to give you an idea of who we are, there we go. We say that in Swedish, vi kan svets, we know welding, we know non-destructive testing, we know industrial heat protection, and we know cobots. So, and of course, we educate the industry. These are our pillars behind Svenska Elektrod. Now, in Swedish, an electrode is a manual welding electrode, hence the name Svenska Elektrod. So we're based in that welding industry with repair and maintenance welding, which is something we do a lot in the mining industry. But we're actually not here today to talk about welding per se. We do talk a little bit about it on our booth with wear plates and hard facing and that kind of welding. But today we're actually going to be here talking about, this is one part of it, this is one slide, collaborative robotics. What is a collaborative robot? Is there anyone in here who's familiar with the term collaborative robot? One. That's good. So I'm speaking to you, but I also apparently have some listeners looking at this live stream as well. That's why I'm looking at up there sometimes as well. So a collaborative robot is basically a robot with a lot of implemented safety features, making it safe to work around as an operator. So we can actually do tasks side by side with the robot. Now we are the certified system integrator of Universal Robots, which is one brand of collaborative robots. And their particular range of cobots are these as of today. They have a small one, the UR3, the UR5, the UR16, and the one I have with me on stage here is a UR10. So the 10 is related to the payload, what it can be put in the fist of the robot. And when that was launched, it could handle 10 kilograms of payload, hence the name UR10. But today, this has been revamped in servo motors, etc. So now we can handle 12.5 kilos. Why is this collaborative then? If we look at we're an ABB country, right? So why is an orange, nice looking robot? Well, today they're white, but they used to be orange. Why are they not collaborative? Well, in the old industrial robotics way, we implemented all the safety features outside of the robot. But in this robot, we have safety measurements in all 6 axes of the robot, which means that when that robot is moving and it comes in contact with me, it stops automatically. Which means that we can do certain things with this robot that I'm going to be talking about in a little bit, that we can work in close vicinity of the robot, which makes it a lot more efficient than doing it only manually or with only robotics. That was the only slide about the collaborative robot apart from the actual application. The thing that's sitting in the fist of that robot right now is an XRF tool, an XRF instrument from Evident Scientific. Now, if I say VANTA or if I say Delta, most of the people in the mining industry, they hear Olympus, just recently, and before that, Innovex Systems. So what's just happened is that all Olympus equipment related to XRF are now in a company called Evident. It's the same people, James Parker sitting up on front row. You were Olympus, now you're Evident. So, and we are the distributor of Evident in these kinds of XRF applications in Sweden. Now, the VANTA handheld XRF tool has been around for quite a long time now, but just recently we've launched the VANTA iX. Yeah, you can actually hand that to me. Thank you. So this is the VANTA handheld. And basically what we've done is that, well, actually Americans put it in a quite funny way. The Americans call this the brick on a stick, and they call the VANTA iX the brick. And that's basically what it is. It's an XRF tool. And what we've done is we've taken everything from the VANTA handheld and we've put it into a tool that's really made for automation application. And what you're seeing today is I've put it on a robot arm, a 6-axis robot arm, but we might as well put it on a linear actuator, or we might as well put it underneath a table where we put pulp bags onto it. We don't need to limit our mind as to putting it on a collaborative robot. The only reason I'm showing it to you in a collaborative robot fashion is that it's quite convenient, it's easy to program, and it's going to open up your mind as to what you can actually use these kinds of robots for. Now, just giving some of the headlines of this tool, it's basically got everything that the VANTA handheld has already. So the Axon technology, making it super fast, making the throughput really efficient and very reliable. But it's also super easy to integrate. They've developed it in two ways. So we can use either a discrete input-output protocol with a PLC, for example, if you have already an automated system, or you want to put it somewhere in a line position. Or we can use an API. So if you have a software where you want to throughput the data to, or you want to gather information for controlling the unit itself, you can use that API. And of course, as the VANTA, it's super rugged. It has IP54, it's standard, military standard grade testing, etc. for dropping it. And the connectors on the back side, you can come up and look afterwards, are super robust. Looking at it a little bit closer, since I can't bring you all up on stage looking at it right now, we got a heat sink on top. We have the X-ray aperture in front with a toolless changer for the sheet in front. This front wear plate is easy to remove, so it's really made for industrial applications where we'll have wear and tear. Just making it modular for those technicians in the field to really make it work every day. If we look at the outer case itself, we're mentioning the mounting holes. Right now I'm utilizing 4 mounting holes to put it in the robot nose, but we have robot holes from, or mounting holes from all sides, making it very, you can put it basically in any configuration you would need. Also, we have all the connectors on the back side. So we have the Ethernet connection for sending, like using the API, or we can have a web listener. So if you come to our booth later, I can show you where we're actually looking at what's happening in the tool while we're doing it. Also, we have 2 discrete I/O settings that I'll show you a bit later what they're up for. And then you have the X-ray warning LED that you'll see in action a little bit later. And also, if you want to be powering it through auxiliary DC power, that's also one of the ports in the back side. Just a little bit about the Axon technology. So when Olympus purchased or acquired Innovex, the Innovex was the birth of the Delta series of handheld XRF tools. Now all the subsequent models in the Delta series were all based on the same technology, but when Olympus developed the VANTA, it was a complete revamp of everything. Electronics, technology, everything corresponding to each other. And that's what they called the Axon technology, which is basically a very, very precise and stable algorithm protocol for doing the XRF measurements. And one of the best things I'd say is and that's the question I get from customers all day long who have had the experience of using handheld XRF for some time, is that, okay, when do we need to do our cal check? To check the 316 coin, to check for that everything is within the spectrum. And we don't need to do that, because with the Axon technology, we're actually doing that with every single test. So we're checking the boundary conditions of the spectrums, we're checking everything with every single test to make sure that we're firing properly. If we're not firing properly, we'll have an error, not even presenting the actual data to the end user. Yeah, and also, so in the VANTA handheld series, we have GeoChem 2-beam, we have GeoChem 3-beam for mining applications, we have Alloy Plus, we have oil, we have ROHS, we have loads of different calibrations and methods, and all these are being able to put to use within the VANTA iX. So no matter the application that you're looking for to automate with the XRF, you can do it with the VANTA iX. I've already mentioned this basically, but they really put them to the test. It basically looks like an IKEA test lab where they sit the chair for 50,000 times. That's basically what they're doing. And they're doing this to every part of this structure. So they're looking at the IP rating, they're looking at the vibration tests, the heat and cold environments, etc. And depending on your applications, you can use them with either ProLean or capped on mesh windows. If we're now looking at how to integrate this, I mentioned this briefly, but we can use it either with the VANTA Connect API, and this is readily available for anyone who wants to develop for the VANTA. And this is then done using Ethernet, so we're sending commands through JSON protocol to the API, answering and posing questions. Or we're just using a PLC. So I can show you that in our booth as well, but we can just hook up a cable with 12 different inputs and outputs that are readily configurable directly as standard, and then we can define pass-fail arguments. So we can tell a sorting line of some sort that raise a flag or dump out that to a scrap bin because of some sort of pass-fail argument. And we can set up multiple, 16 actually, of these. I said that they're testing things robustly. When we're looking at the WebSocket design, this is something that they're testing very, very continuously as well. They're doing over 35,000 tests when they're redoing that 24/7 for a month. So it's really stable. And the protocol itself that we're sending through is JSON, but if you have experience in C++ or C# or Python, then you can write all the script code in those languages and then just passing it through and communicating it with JSON. And as I said, the user SDK is available with every purchase of the VANTA iX. And you can also run it, which is very, very useful for testing applications. You can run it manually with the PC software. So just hook it up. So on the back side, we have two I/O pins. You have the factory set inputs and outputs, and you have the operator inputs and outputs. And what I'm hooking up to now are the factory presets. So I can start a test. I can listen for if the radiation is on. I can listen for if the system is ready for taking a test. I can listen if there's any fault. And I can also have an interlock switch activating so that the unit cannot fire while the robot is moving, for example. And we can input that to a proximity switch. Depending on the application in the end, what we want to be using it for, we can hook it up to many different scenarios. The 8 user configurable I/O pins are the ones with a little person connected to. And we can then input pass-fail arguments, as I said, but we can also define different profiles. So we can trigger different tests with the user-defined I/O pins. So if we have different settings, we can use the I/O pins for that, for example. So the PC software that we hook up to, if we want to use if you've used the VANTA handheld, you're used to the PC software already, but there's also the same one, basically, but it's for the VANTA iX. So you can set up all the different pass-fail arguments, you can set up all the different grade profiles, your libraries, etc., and user factor correction for your matrix, etc. All of this is set up in the VANTA software. And you can also use it for manual control for testing, but then we also have the web app. So say, for example, you're setting up a station with this one, and you want to press play to run the program, but you want to see also what's happening. Then we can just have a little Ethernet connection that's actually also powering the unit over power over Ethernet. So we actually more or less just running one cable down the robot arm. And then we can just log into that and listen to the instrument to see what's actually happening. If you've ever seen these kinds of systems before with automated XRF, Olympus has had one, which is called Fox IQ. And this is just to sort of relate the new instruments to the Fox IQ, the previous version. James, are there any Fox IQs in the geochem industry? No, basically not. I think it's only in like bar control systems, etc. Yeah, not bar that you're drinking, but the steel bar. So the Fox IQ was very, very high priced, and it was quite poor in performance, hence not being used in the geochem industry. But we've now put 2 VANTA iX systems, one which is called the VANTA M series and one which is called the VANTA C series. The difference between those 2 series are the size of the detector. So the M series has a larger, they're still silicon diode detectors, both of them, but the M series has the big one and the C series has a little bit smaller. What does this do? Well, if you're comfortable with XRF, you know that the bigger detector, the more counts you're going to get if you can handle it, which means that you'll have a higher performance, higher throughput, etc. And these are about, you know, a schematic way of putting them in terms of price performance-wise. And also the C series features a tungsten tube and the or tungsten anode, and the M series, the VANTA iX M, has a rhodium tube. So if we're looking at what we could do with this in this context that we're in now, Euromine, we could use it for drill core analysis. I'm just going to show you a quick little sample test down here in a few minutes. And the benefit of this is, of course, you're getting a full spectrum chemical analysis of the drill core. And basically, if you have an oriented core tray with drill core, then it's super convenient because someone is still going to stand there and do those tests, because that's usually the way you do. So why not just put him there? Or by him, I'm talking about the robot. Or you can use it for continuous monitoring. Definitely for like blending verification and making sure that your processes are running the way you want them to. That's it for my slides, but now I'm going to show you the real stuff over here. And I want to say with this, because since I'm an advocate in this industry about automation and automation in industry in general, we come from the welding industry, but we are working with integrations with robots in many different fields. Dennis, sitting in the back, is doing machine tending applications, helping labs unscrew caps, doing so basically anything that's repetitive and or dangerous. Why not just put one of these guys there? So wherever you are in your industry, don't limit your mind as to what you can do with these tools. So one of the benefits with using these cobots is that you can do the programming very, very swiftly by actually moving the arm to whatever you're going to do with it. So basically, when I push a button back here, it's called that it's in free drive mode, which means that I can pull the robot to any location I want it to go. And I said that this is a UR10E. I said that it has a payload of 12.5 kilos. This particular payload sitting here right now with the cables and everything, that's about 3 kilos. So it's not going to wear out your robot arm. But what I didn't mention is how long you can reach from the base. So it has 1300 millimeters of reach from its base. And those 1300 millimeters are related to this nose flange over here, which means that if you're putting on something out here, that's going to be adding to those 1300 millimeters. But one thing to note about that is that the repeatability of this particular robot is plus minus 0.05 millimeters. And plus minus 0.05 millimeters is related to plus minus 1300 millimeters from the base, which means that anything we put on the extension here is not accounted for when we look at the repeatability. So you need to take that in mind. But plus minus 0.05 millimeters is far more precise than any of us. So we have 6 axes to play with: the base, rotational, the shoulder, the elbow, and the 3 wrists. All of these wrists in this robot can rotate plus minus 363 degrees, given that the geometry and everything are up for it, so to speak. On the smallest robot, the last wrist number 3, is infinitely rotatable. So you can actually use that for drilling applications, just putting a drill bit and then using that. Maybe not drilling, but at least screwing something in. Another feature that's in this robot, and then I'm going to show you in just a few seconds, is that we have a force sensor in this nose. What does that mean? Well, this core tray, for example, isn't always even. It's a piece of wooden box that's put together of sometimes it looks like scraps. When they're new, they don't look like this, of course, but they're a bit uneven. So finding the right position in height isn't always easy. And in this particular program that I'm going to run now, I'm actually using the force sensor to tell the robot that when you're in this position, push down with a force of 11 newtons. And once you hit something, 10 newtons, since something is going to react back, stop there and then do the tests. So I'm just going to reposition this core tray, making sure that we actually hit something. Something like that. Just going to check the first position, and then I'm going to walk you through what it's doing. There we go. We're going to hit something, definitely. So what it's doing right now is it's actually going into position, I've defined 4 different locations on this core tray. I've defined the first position over here. I've defined the last one in the first row. I've defined the last one in the last row. And then I've defined the first one in the last row. So 4 locations of the core tray. And this can be automated as well, because not all core trays look the same. So we can actually put a little vision system on the flange of the robot, looking at the workpiece to start with, to then define the different coordinates to make sure that we always hit the core. So what I've done then is I've told it that, okay, this is the outer boundaries, and then in those positions we have six different columns, and I want to do 10 tests on every column. Then it evenly distributes those 10. If we instead wanted to define the distance in between each test, we could of course do that. But the beauty of this is that the speed of doing this programming is super fast. Literally, it took me maybe 5 minutes to do a program that can then be repeatable. It's been run several hundred times today in our booth. And it's just go and do the same all over again. And the beauty of it is that the robot then records everything it's doing, which means that for every test, for every time it starts an XRF test, it also gives the coordinates for that test, which means that it can then report back to any other software. If we're just putting up the result in a server, in an Excel or an XLS file, we can then include not only the measurement data, but also the position from the robot. So what does that mean? Well, it's an XY pattern, which means that we can relate all the positions in this core tray to the XRF data. I'm thinking how far this will go, but this is probably the last position. So think of it in a drill core facility where you have loads of these, and you have a conveyor belt where you mount all the drill core, or all these core trays. You orient the core, then you put up a couple of sensors, which then control and give the robot a signal, hey, I have a core tray in place. That means that the robot's going to work, because you've already started the program. So when that core tray comes, it's just going to start the work. Then you can start orienting the next core tray. And once the robot tells the conveyor, hey, I'm done, pass me the next one, then it's just going to open up the conveyor again. The core tray is going to move along, and the next one is going to come and give the signal, and just repeat that process. That's one use that you could use it for. If you're doing analysis in a lab, you're looking at pressed pucks. Well, we could automate that procedure by not having a precise placement of that puck. Because maybe you want to do, you just want to, when you've pressed those pucks, you want to put them in a position, and then you want the robot to work. Then we could have an easy XY vision system detecting where that puck is, telling it where the robot should place the XRF, and then do the test. Because all the programming of this one is done in relationship to something. Just going to stop it when it's not testing. All programming is done in relationship to, first of all, a base coordinate system, which means that we have an X, Y, and Z with the relationship to the base of the robot. What we're basically doing here, when we tell it that this is a core tray, is that we are actually telling what coordinate system is down here, and we're relating all the programming to that. But the other thing that it's relating stuff to is not the coordinate system, it's actually what's called a tool center point. So if I rotate the robot with relationship to the tool center point, you can see that it's actually rotating the robot in relation to a fixed point. What does that mean? Well, it means that if we use a little vision to detect where that puck is, very precisely in XY, we can then also tell it that you should mount your TCP to that XY pattern, and then have a very precise measurement every time. And since this has a plus minus 50 micron in repeatability on the robot arm, we'll know that the air gap isn't too far off. Those are my words. Those are that's what I wanted to tell you guys, and I hope you found it interesting. I hope you find it a little bit refreshing for your mind what you can do with these tools. And if you want to see more of this, we've done a long webinar that's on our YouTube channel where we've done this is exact setup, but a little bit more in detail, and where we're actually doing tests and looking at the data, etc. So that's on there. And feel free to come to our booth and look at it a little bit more in depth. Thanks.
Hello, good afternoon. Thank you for joining me for this short presentation. It's the last one of today, and forgive me if I'm a little bit slow or rusty because I haven't done this for more than 2 years. So, the title of the presentation is Environmental Intelligence and what is the risk of doing nothing. But before I proceed with this, I'd like to tell you a bit about myself and the company that I work for. So my name is Gary Logan. I'm responsible for sales in Northern Europe and the Middle East. And the company I work for is EnviroSuite. The EnviroSuite is a software and solution provider who have developed solutions for environmental intelligence that supports many complex challenging issues, both in airports, both in the mining sector, wastewater, and waste management. We originated in Australia, but we've grown exponentially over the past number of years, where we're actually present in 15 different offices across the globe. So, what is environmental intelligence? Well, we take environmental information, so that the core of it is environmental data. So we take operational data, excuse me, such as noise, water, weather, dust, and air quality, and also vibration. And through our own platform, using a mixture of machine learning, decades of experience, and proven scientific data algorithms, we develop predictive models, automated compliance reporting and analysis, real-time smart alerts, and it provides the customers trusted insights into the quality of the data and the issues it's generating. But finally, using that information, we enable our clients to make much more informed decisions, such as an increase in production, tangible cost savings, optimized operations, and also, quite importantly, social license to operate. And so therefore, environmental intelligence is about supporting. The environmental intelligence, in summary, drives and supports confidence decisions through the use of intelligent real-time environmental data. And as you can see from this slide, with the rich environmental information, we can support strong decisions, confident decisions by the the mining community. Now, in English, we often have a saying as playing devil's advocate. You know, why do we really need it? What happens if we do nothing? What are the risks? Can we continue as normal? Well, let's take some examples that have been defined by many mining executives that are classed as really environmental risks. And I'm going to look at 4 examples: safety, social license to operate, operational efficiencies, and ESG in mining. So for people who are not familiar with ESG in mining, that's about environmental, social, and governance. And I'll talk about that in a few moments. So if we take safety to start with, this is really about the safety of employees, community health. Safety is paramount and remains at the forefront of the industrial focus. So if you've got poor health and safety performance, this is often unacceptable and can have serious ramifications, including loss of license, disruption to operations, and in some cases civil and criminal liability. God forbid if you have a fatality, the consequence is quite severe. Social license to operate. What happens if we do nothing? Well, the community, if you've got community unrest, can result in deteriorating relationships, lawsuits, disruptive operations, and negative impacts on the company image. It's quite severe. There can be real financial impacts on that. Operational efficiencies. Again, what if we do nothing? Unknown environmental risks can cause abrupt operational changes, downtime, or inefficient use of resources to control unwanted impacts. Any one of those could have serious financial impacts on the operation of a mine. And lastly, ESG in mining. So it's become an industry standard in which you measure the effectiveness of that mining or that facility against industry standards. And fund managers or ethical investment uses this to measure the effectiveness of the mine and basically how it's doing the right thing. And if the mine is not doing the right thing, then you won't get investment, or investment might be restrictive. So before I progress any further, EnviroSuite, as I mentioned, develops a number of serious different software applications. And one of them which underpins environmental intelligence is called EVS Omnis. It's a support framework that enables you to connect disparate environmental information such as air quality, dust, water quality, noise, odor, vibration, and meteorological information into a common single environment. And that's what underpins the support for environmental intelligence. So I'm going to take sort of those three examples, which is really around social license to operate, safety, and operational efficiencies. And I want to show and describe the benefits what the environmental intelligence tools offer to mining. So let's start with one important thing is dust exposure. Excuse me. One of the biggest challenges is workforce and community. EVS Omnis, which is a software platform we spoke of, provides invaluable insights into real-time management of site-generated emissions and contributions from local weather. It enables the software platform enables you to understand, visualize, and in real time how that site is behaving. And that enables you to mitigate unfolding site emissions before they become bigger or more of a problem. Knowing when you're operating within the thresholds, and if you have an exceedance, then alerts are automatically generated instantaneously to inform you if something is anomalous or, more importantly, is going to cause a problem. Furthermore, if you can identify zones of risk that will impact the workforce by using real-time monitoring, that's such an advantageous approach. And also presenting this information in an easy, usable, understandable method of reporting to stakeholders and compliance individuals is advantageous as well. Lastly, is being able to forecast dust risks for the workforce and the community. So I spoke about real-time monitoring, but what happens if you can articulate or describe the suitable factors, such as particular meteorological information, can have on impacting the community or the workforce that are working with you. So within the platform, we have that ability to forecast those dust risks and present it as a manner that is based on that you can be used to plan in advance. So for example, if you have a situation where in 48 hours time you know that there's going to be meteorological information that's is going to be conducive to generating dust events, then you can alter the work pattern. You can better prepare your workforce to ensure that they're not present during that time when they have a dust event. Another example for safety, wall stability, especially around pit walls and tailings dams. Because the platform is so agnostic, it enables almost any information to be presented within the platform. So for example, if we can measure things like monitoring key indicators such as movement or groundwater pore pressure. Then we can see when events are happening, what's the risk and what are the trends. So by using sort of advanced analytics, we can identify trends within the data in real time and report and alert to the appropriate individuals of an impending problem. So it could save lives. Lastly is also operational noise and vibration impact. Now, almost as important as dust, operational noise can impact a person's hearing, and more importantly, or not as more important, but potentially identify the sources of those noise events. Those noise events could be related to, for example, a piece of equipment that's not being maintained correctly, or it's failing, and if it fails, it could cause loss of life, as one example. So within our platform, it enables us to analyze not only the experiences, but also the detailed frequencies that will identify the appropriate equipment that's failing or causing those noise events. Next one is the social license to operate. So the challenges with this are fairly quite simple, is that a mining activity will impact the community in some shape or form. And whether we like it or not, the community will be emotional, they'll be angry, they'll want change, and it'll affect their health. So if there's any way in which you can actually proactively monitor what's happening in the site, and more importantly, understand what impact you're going to have to the community, is an advantage. So within our software platform, it enables you to, as I mentioned earlier, perform real-time monitoring. You can forecast risk, but also if you've got complaints that are being reported off-site by, say, the community, we can very quickly identify the source of that, say, dust event that's caused the community to complain, using sort of innovative modeling techniques. So for example, here it enables you to investigate complaints in a much shorter period of time. So for example, as you can see in this slide, where my cursor is, oh, can't even see that, sugar. Anyway, the pinpoint of the complaint location in the community, we can model the parcel of air to understand and present and visualize this, where the air came from, to identify the source of the problem. And if you can identify the source of the problem, then you can have a very good chance of mitigating it. And also being able to present this information visually to the community will diffuse maybe awkward situations or emotional situations that's caused the complaints to happen in the first place. So it's all really about complete transparency. And this is what the platform provides, to name but a few things. The next category is dust mitigation, which is, as most people are aware, is expensive. So therefore, if there's any sort of insights that we can provide to the operational activities of the mine, when activities are evolving, then that can trigger something called a triggered action response plan. So basically, if a certain part of the mine is showing a dust event, then we can trigger a process which they will follow to establish its level of severity. In addition to that, what equipment they need to use to suppress that, i.e. how much chemicals we're going to use, what equipment they're going to use from a PPE standpoint. And if you can identify accurately where those events are taking place, then you can reduce dust suppressing costs, reduce call-out times, lower your man hours in effect, and also manage the risk to your manpower, or workforce, I should say. So that I mean, in some mines that can run to several million euros a year. So if you can reduce that by quite a margin, it can save you a lot of money. Another scenario is modeling blast impact. So with blasting, the major problem is a mixture of dust, but also within the dust is the fragment size of the rock it's being blasted. So traditionally speaking, this is most mines take quite a conservative approach when they build what you call a blast fume model, where they sort of overcompensate for risk. They'll create much larger protective zones than they probably need to, and as a consequence, they're not blasting as much as they possibly could. So with what we're able to do is to use simulated approach to simulate, one, how far the blast will travel, two, who will impact, and three, can we also protect our workforce, the local community, and also our equipment. Because people seem to forget that if you've got a blast event, the amount of material that's generated from it will damage your assets, which are very expensive. So if you can protect those and simulate those simulations, such, for example, the slides that you can see in front of you. The one in the top right corner indicates that it's heavily influenced by the wind direction going to the north-northwest. So we use the meteorological information to forecast those scenarios. So the benefit of that is not only modeling more accurately and simulating more accurately, but more importantly is that you can blast on days that you think are too risky. Because if you can manage risk by simulations with real data inputs, then you can blast on certain parts of the day that you weren't sure you were able to do. So to bring this to fruition, what I spoke about sort of earlier on in the presentation was the value environmental intelligence supports ESG, environmental social governance. As I mentioned, this is a method in which they measure against an industry standards or how effective the mine is as adhering to these standards. Is it managed in relationship with the community? Is it being proactively monitoring? Is it protecting its assets, which in many cases is the workforce? So therefore it's all about managing risk. So no one really likes taking unnecessary risks, especially when it can disrupt or even halt a critical project. So here are some of the ESG risks that can be mitigated by considering the benefits of environmental intelligence. So again, I reiterate, by being able to provide the appropriate environmental information in an appropriate manner can de-risk situations. So for example, unhappy communities are disrupted through expansion or operation of a site, failed tailings dams and community pollution resulting in loss of licensing, disruption to operations and civil or criminal liability, poor planning and design physical climate change risks, and efficient use of scarce resources like water, which is very paramount, and energy, which is very relevant at the moment, threatening business continuity, and also poor workplace health and safety can result in loss of licensing. So really the bottom line is that if you're able to measure the effectiveness of the ESG, de-risking it, then it makes the business or the mine much more investable because people will get a return on investment. So I went through that fairly quickly. If there are any questions, if they're not, then please come and visit us. It's actually not booth 206, it's actually 236. That's an error on my side. But if you have any questions, please come over to the stand. Myself and my colleague will be happy to help you. Okay?